Welcome everyone to today's technical workshop on wastewater treatment. My name is Darcy Peth. I work for Raw Strategic. We are contractors to King County Wastewater Treatment Division. Welcome to the workshop. This workshop is a bilingual event. Please look at your Zoom toolbar and click on the interpretation button and select either English or Spanish. Next slide. All participants should select the interpretation button at the bottom of the Zoom screen and pick either English or Spanish. To hear Spanish audio of the workshop, you must join by computer using either computer speakers or headphones. Spanish interpretation will not be available if you dial in using only your phone. Spanish listeners can mute the English audio by clicking on Mute Original Audio under Interpretation. English and Spanish closed captioning will be available. English will be available through the live transcript button. Spanish will be available through a link in the chat window. Next slide. Before we start the presentations, we want to cover a few tips on how to participate in the webinar. First, you are all muted, which we have done to reduce background noise to improve everyone's experience. If you can't hear us well, you can adjust your volume by clicking the microphone on the bottom left. If you have technical issues or questions about connecting to the webinar, you can click on the chat option in the toolbar. This will send a chat message to the webinar host. Turn on closed captions by clicking on the Live Transcript CC button. To ask questions about the presentations, click on the Q&A icon in the Zoom toolbar at the bottom of your screen. Note that this is different from the chat box. We request that you use the Q&A box to help us make sure we get a chance to read your question aloud. You can submit questions at any time during the webinar, and we will answer as many as we can during the designated Q&A portions of today's workshop. Please be sure to type your question using complete sentences so that it can be understood clearly when read aloud. We may not have time to get to all the questions today, but you can follow up afterward by emailing cleanwaterplan@kingcounty.gov. If you prefer to participate verbally, please click on the raise hand icon, and during the designated Q&A portions of the workshop, if time allows, we will call on you and unmute you so you may speak your question. About a week after the workshop, a recording will be posted online as well as the slides. And again, this workshop is a bilingual event. If you have not already done so, click on the interpretation button on your Zoom toolbar and select either English or Spanish. I will now hand over to Sonia Lynn Abenahar to take us through our next couple of slides.
Good morning, everybody. This is Sonia Lynn Abenahar. I'm one of the project managers for the Clean Water Plan. I want to thank everybody for taking the time out of the day to participate in this virtual workshop. And as everyone gets settled, please feel free to use the chat box to share your name, affiliation, and why you are joining us here today. And before we launch into the workshop, I want to begin our time together with a land and labor acknowledgement and also share a message from our King County Executive, Dow Constantine. We would like to acknowledge that we gather today on the ancestral homelands of the Coast Salish peoples, who have lived in the Salish Sea Basin from time immemorial. And we acknowledge that we benefit from the prosperity of the United States, which was built on the labor of enslaved Black people. Please join us in expressing our deepest respect and gratitude for our Indigenous neighbors, the Duwamish people, past and present, and other coastal Salish peoples for their enduring care and protection of these lands and waterways, and for the African American descendants of those who built this country. I also want to share some words from a message from Executive Dow. The trial over George Floyd's killing resurfaces many painful memories and emotions for all of us, and especially for Black people and all people of color in our community and in our workforce. The aggression, racism, and violence aimed at Asian and Pacific Islander Americans coming at the same time as the trial leaves us raw and heartbroken. These events put a spotlight on the racial injustice, inequality, and violence that Black, Indigenous, and other people of color have experienced in this country for centuries. It should also push us forward together with urgency to stand against racism in all of its forms, entwined in every institution. I just want to thank everybody for taking the time to listen with your hearts. And I want to now pass it back to Darcy, who will walk through today's workshop agenda.
Thank you, Sonia. As you can see, we have a full agenda today. We will begin by going over your wastewater treatment system and wastewater treatment concepts before we have our first question and answer session. We'll then hear a presentation on regional wastewater treatment actions before our second question and answer session, which will be followed by a break. We will then hear about decentralized wastewater treatment actions, which will be followed by our third question and answer session. We will then hear an introduction to and overview of the actions related to pollution source control and product stewardship, followed by our fourth and final question and answer session. And then we will go through some next steps and we will adjourn. You'll be hearing from several people today. From King County, we'll hear from Steve Toltzman, Tiffany Knapp, and Sonia Lynn Abenahar. We'll also hear from expert technical consultants, Ian McKelvey and Elizabeth Lowell. I'm Darcy Peth and will facilitate along with my colleague, Rob Greenwood. We'll also have a number of subject matter experts who will be available during each of the Q&A sessions to answer technical questions related to their area of expertise. I also want to note our presentations today will summarize some of the information in the document Actions Characterizing Water Quality Investment Options, which you will hear referred to as the Actions document. A section and page number references will be provided when the slides are posted online. Before we begin our presentations, a few things to keep in mind for context as you hear today's presentations. These workshops are taking place in the middle of the planning process. At this stage, we have built and characterized a range of potential options using substantial engagement and analysis. Engagement has included tables at fairs and festivals, webinars, an in-person workshop, engagement with community-based organizations or CBOs, an ongoing external advisory group, and more. The scope of programs we are exploring and the methods used to characterize them are the result of input from the community and subject matter experts inside and outside of King County. We chose an exploratory planning process for the Clean Water Plan that involves looking at a range of different water quality investment approaches to guide future investments. This process will allow the county to fully investigate the potential for better water quality outcomes. This workshop series has been structured to provide details and background on this step of the process, actions, so that interested parties have foundational information about the choices and opportunities. As we mentioned, you may still have questions after the workshop. You can send those to cleanwaterplan@kingcounty.gov. I'll now hand back to Sonia for our first presentation. Sonia, you're muted.
Thank you. Thanks, Darcy. Hi again, everybody. In this next section, I'm going to walk you through Clean Water Plan background information, where we will share a new video about the Clean Water Plan that will walk you through the overview of the planning process. We'll also share some grounding information about today's workshop on actions and the water quality investment options the county could take in this exploratory planning process.
Clean water is what makes the Northwest special. Puget Sound and our lakes, rivers, and streams give us food, transportation, jobs, and fun. Why should you care about wastewater in our region? King County's wastewater system is vital to our community. It collects and cleans the water that people send down the drain and protects public health in our rivers, lakes, and Puget Sound. The Clean Water Plan will guide King County investments that protect our waterways, the environment, and public health for decades to come. King County has tough decisions to make about the future of our regional wastewater system. We need to plan for current and proposed regulations, fixing aging pipes, pumps, and tanks, population growth, and how to pay for the investments which will cost billions of dollars in the coming decades. While doing this, we need to keep other important issues like equity and social justice, our future climate, and costs in mind. And your voice matters. The Clean Water Plan process will allow us to thoughtfully navigate the different choices and opportunities so we make the right investments at the right time for public health and the region's rivers, lakes, and Puget Sound going forward. Here's how the planning process works and how you can make your voice heard about the issues that matter to you. First, we look at different choices and opportunities that need attention across our wastewater system. Things like how we move wastewater to the treatment plants, how we clean it when it gets there, how we manage extra water during wet weather, how we care for our aging system, how we recycle treated wastewater, how we clean up historical pollution, and keep new pollutants out of our wastewater. To build the Clean Water Plan, we are exploring a range of actions to address our wastewater and water quality challenges. Actions are the moldable building blocks that will be shaped and combined through the planning process. Understanding individual actions is a start, but we also need to look at how they interact over time and how they affect water quality. The next step in the Clean Water Plan process is to put individual actions together into strategies, which are different complete approaches to investing in water quality and our regional wastewater system. We developed several strategies that will help us explore the choices, opportunities, challenges, and results of each approach. Then, King County uses what we learned from both the community and technical analysis to assemble a single preferred strategy and financial plan. Finally, King County Council votes on a final plan. All along the way, community input is vital. Since the 2018 decision to begin a clean water planning process, King County has invited public input. Community priorities and equity considerations help shape the developing plan. As we move forward, we invite continued input through future workshops, questionnaires, public comments, and participation at every step. Thank you for exploring the Clean Water Plan with us. Please get in touch. Find out more at kingcounty.gov/Clean Water Plan.
The Clean Water Plan is an exploratory process. Through this process, we are working on interrelated, complex problems, which are listed there on your screen. And we often call these the Clean Water Plan decision areas. This slide shows a complete list of the decision areas that the county is exploring. And today we will be covering the ones highlighted on your screen: the wastewater treatment decision area and the pollution, source control, and product stewardship decision area. So in this workshop, we will be talking about the range of new and different approaches under those two decision areas: wastewater treatment and pollution, source control, and product stewardship. And what do we mean by actions? Actions are specific programs, projects that address one of the decision areas the plan needs to consider. Actions are designed to address particular wastewater or water quality challenges. Actions are not standalone water quality solutions. They are building blocks that will be shaped and combined in different ways throughout the planning process. The Clean Water Plan is exploring some actions that would require significant changes in how we do things. We are also exploring actions that are consistent with our current practices. This will provide us with a wide range of options so that in the next steps of the planning process, we can pull together a complete picture of what water quality investment approaches could look like. And today we are sharing a technical characterization of the actions we are exploring. We did this analysis to help us understand what would happen if a specific action were implemented. We did not collect any new data or complete any new water quality characterizations. Instead, for actions that are directly linked to past and existing county or regional activities, we relied on existing and historical plans, reports, and project information from King County and other entities in the region. For actions that are new concepts for the county, we looked at other programs in the nation and industry, case studies, and trends. And here are other considerations continued. When we talk about water quality performance estimates, we are looking at the following: water quality parameter load reductions, pathways for how pollution enters the waterways, and the water bodies most likely to be affected from the actions we are exploring. We also developed conceptual program planning estimates for the 40-year planning horizon to provide us an understanding of the order of magnitude of funding that would be needed for the conceptual program. I will get a little deeper into water quality and program planning cost estimate characterization in just a moment. Okay, so first we want to talk about what we mean by water quality parameters. Water quality parameters are things like bacteria, nutrients, heavy solids, organic chemicals, and flow. These parameters were selected because of their potential connection to human and aquatic health endpoints. We also considered the potential impact they have on the environment and water quality, any linkages to identified water quality impairments. These are parameters that King County activities could plausibly influence, and where data is available to measure and describe their impacts. When selecting these parameters, we also considered other ongoing and parallel King County water quality related efforts. When we explored the range of actions the county could take, we saw how each of the actions performed across all of these water quality parameters. It should also be noted that all load reductions and potential for flow reductions were estimated quantitatively, except for any actions that had the potential for reduction in contaminants of emerging concern. These were described qualitatively because current loading is not well documented. What you see on your screen are pathways that transport pollutants into Puget Sound rivers and lakes in our region. For example, wastewater treatment plant treat sewage from homes and business, then discharge it or return it to the environment. Combined sewer overflows are overflows of untreated wastewater and stormwater. Some pipes carry both sewage and stormwater into a treatment plant. When heavy rains fill these pipes, they can overflow into local water bodies to prevent backups into homes and businesses. Stormwater is rain that runs off streets, parking lots, driveways, lawns, and sidewalks and picks up pollutants. Stormwater can also run off fields and other lands in rural areas. Contaminated sediments. Sediment is the soil or sand on the bottom of a water body. In some parts of the region, sediments are contaminated from past industrial and commercial activities. So what water bodies is the Clean Water Plan considering? The pathways have the potential impact multiple water bodies in our region. The Clean Water Plan considered the following list of water bodies, and when characterizing actions, identified which of these water bodies are most likely to be affected by the action. And to ground you further in the planning process, we want to acknowledge that many of you are interested in understanding impacts to human and aquatic health endpoints. For example, impacts to recreation, shellfish harvesting, edible fish. In these workshops, we are characterizing actions using data focused on specific pollutants. For example, metals or PCBs, and the amount of water that carries these into our local water bodies. But this is just the beginning. In future phases of the Clean Water Plan process, we'll put individual actions together into complete strategies. Then we'll be able to explore the broader impact the strategies have on water quality, including the benefits to people, salmon, and orcas. brings us to our next topic, which is how are water quality parameter loads estimated for the plan? Estimates of water quality parameter load reductions were determined by developing estimates of concentration and flow rates. For the wastewater treatment and pollution source control actions we'll be discussing today, this included historical data of flows entering and leaving the treatment plants, regional water quality monitoring data, and other available literature. Based on the specific components and activities or projects within an action, we determine the changed conditions, such as changes in population or treatment approaches, and use this to estimate the potential change in water quality parameter loads. Later in the workshop, you will learn more about conceptual program planning estimates of the action. We want to share upfront how these estimates of specific component projects of activities of the actions were developed. So we used costs from existing King County studies and historical cost, revenues, and standard labor rates, information from comparable programs or other projects in other areas of the United States. The estimates we'll be showing you are for the full 40-year planning horizon and are shown in the accuracy range from the lowest, most optimistic to plus 150%. These estimates are based on guidance provided by the Association for the Advancement of Cost Engineering. And these account for the uncertainty in cost estimating a planning level concept, as well as how the scope and details could be impacted over a 40-year planning horizon. The purpose of these conceptual program planning estimates are to provide an understanding of the order of magnitude of funding that would be needed for the action. And here are the program planning estimate components. They can be broken down in this way listed on your screen. Estimates of each of these for each action can be found in the document that Darcy mentioned earlier called Actions Characterizing Water Quality Investment Options, which is now available on the Clean Water Plan website. So to run through this list, conceptual capital are the estimates for both new infrastructure and soft costs like design, labor, and permitting. Operations and maintenance and administrative are things like labor, energy, materials, and staff time, which are the costs required to operate infrastructure or administer a program after the action is implemented. Rehabilitation and replacements are the expenses incurred to maintain the system as infrastructure ages and wears. Avoided are costs not incurred when currently planned capital or operating expenses are deferred temporarily or permanently. For example, if a pipeline capacity project could be deferred due to the implementation of a satellite treatment facility. Changes in revenue are any increase in the revenue streams because of new fees or a new line of business. And incurred by others are estimated expenses beyond those borne by King County. These can be expenses incurred by others in the region like component agencies or private agencies. Now that we walked through the background and information on the Clean Water Plan and actions, I'm going to pass it over to Darcy, who will open it up for our first question and answer session.
Thank you very much, Sonia. Next slide. Oh, Sonia, I think we actually have your next few slides before the first Q&A.
Perfect, sounds good. So I'll jump right in. All right, so now that we have the grounding information to the ways that actions are characterized in the Clean Water Plan, I want to spend the next section sharing facts about the regional wastewater system and key wastewater concepts that will help you understand the range of actions that will be discussed in more detail later today. First, I want to acknowledge that many organized efforts, government agencies, tribal governments, and communities all play a role in keeping our region's water clean. Many of these efforts include work to protect our orca and salmon, to keep our water clean, to build healthy habitats, to support green building, and to educate and train our communities. These efforts, along with the wastewater treatment infrastructure and programs, are crucial for protecting water quality and economic vitality while maintaining our region's natural assets like beaches, lakes, and rivers. So in this next section, I'll dive into some background specifically on wastewater treatment and what the county does to keep our waterways clean. And just to make sure we're all clear, when we talk about wastewater, we're talking about the dirty water that runs down the drains from your sink, shower, toilet, dishwasher, or laundry machine, as well as the wastewater that comes from businesses and industries. In addition to the water from your home and local businesses, we are also talking about stormwater that enters the wastewater pipes. Since a portion of the county's wastewater system is combined, rainfall collects in the system and gets combined with wastewater to get clean at the regional treatment plants. And here, I just want to share some quick facts about our regional system that you may not know about. The county's wastewater treatment division serves nearly 2 million people, and the wastewater system operates 24/7 and cleans an average of 180 million gallons of wastewater per day. And over the next 40 years, in 2060, the region's population is projected to grow to 2.5 million. And pointing you over to the map on your screen, I want to orient you to the locations of the treatment plants, which are noted by the yellow squares, A, C, E, F, and G. There are 3 regional plants and 2 smaller ones across the region. C is our West Point treatment plant in Seattle, which treats water west of Lake Washington. F, which is our South plant in Renton, which treats water east and south of Lake Washington. A is Brightwater in Woodinville, which treats waters from areas of North King County and South Snohomish County. And E and G are the smaller treatment plants, which are located in Vashon and Carnation. This map also shows the 4 wet weather treatment plants, B, H, D, and I, that treat combined wastewater and stormwater during large storm events. And here's a little bit more background on King County's physical infrastructure, where you'll see that we have a lot of assets to maintain. As I mentioned, we have 5 treatment plants, 3 regional ones and 2 smaller ones. There are 47 pump stations. These are the pumps that push flow from lower elevation to higher. And there are 4 combined sewer overflow treatment facilities. We also call them wet weather treatment station. And across the system, there are over 400 miles of pipe and about 700 employees handling wastewater for 1.8 million people every day. Many of our assets are over 50 years old, and it would cost more than $20 billion to rebuild the wastewater system from the ground up. So we need to take care of our existing system. All right, so as we dive into the actions around wastewater treatment decision area, you'll see on this slide the levels of treatment we'll be talking about today. I'll briefly share a quick overview of the listed treatment levels so that folks have a baseline understanding. And I'll also note here that the county's existing regional treatment plants all treat the majority of their flow to a secondary treatment level. And as we dive deeper into the details of the actions, my teammates will be focused on the last 3 bullets: secondary treatment, nutrient or nitrogen reduction, and advanced treatment. Here's a view on how our primary treatment separates the solids from liquid in wastewater. Primary treatment uses the screens to remove trash and tanks to remove rocks and sand. These are washed and then sent to the landfill. Primary treatment uses gravity to remove the solids by slowing down the water in the large tanks, and light materials float to the top and heavy materials sink to the bottom. The solids that are removed during the primary treatment are sent to the solids treatment process. And as a heads up, the solids treatment will be discussed at a future workshop where we will cover the resource recovery decision area. The 4 wet weather treatment plants treat to a primary treatment level plus disinfection to kill any remaining bacteria. And now for secondary treatment, which is widely used as the standard for wastewater treatment, since it's an effective process at removing targeted pollutants like solids, organics, and bacteria. This is an existing level of treatment at King County's regional treatment plants. Secondary treatment uses biology to further treat wastewater. So when air is added to the large tanks called aeration basins to support bacteria that break down the remaining dissolved organic material. After aeration, tanks or filters are used to remove the remaining solids. At West Point and South Plant, secondary clarifiers are used that slow down the water and lets the light solids flow to the top and heavy solids sink to the bottom. At Brightwater, membranes are used to filter out the solids. Solids are then removed during the secondary treatment and then sent to the solids treatment process. The secondary treatment system at each facility uses an activated sludge process. West Point uses high purity oxygen to maximize the amount of treatment capacity within a highly constrained site. South Plant uses a conventional activated sludge process with selectors. And Brightwater is our newest regional treatment plant and uses membrane bioreactor technology, which permits high capacity treatment in a limited space. Treated water from these facilities is disinfected and either returned to Puget Sound or treated further and reused as recycled water for industry or irrigation. Nutrient removal is a modification of the existing tanks or addition of new tanks or processes to the secondary treatment process. The aeration equipment and tanks are configured to support a different type of bacteria that break down nutrients like nitrogen that are not removed using conventional secondary treatment. Some nitrogen removal can be done on a side stream. The side stream is the water that comes back from the solids treatment process. And this water has a lot of nitrogen in it. Special bacteria that live in a highly concentrated side streams can break down the nitrogen in a very small amount of space. Side stream treatment can also reduce some of the overall nitrogen going through the treatment processes, but not to the same level as modifying the full treatment plant. In looking at advanced treatment, this removes even more water quality parameters and pollutants. It can involve physical, biological, and chemical treatment processes such as ultrafiltration, ozone, biologically active filtration, or granular activated carbon. Resulting in this process is what we call recycled water, which can be used for irrigation, flushing toilets, supplementing rivers and creeks, and supplementing drinking water sources. The increased treatment includes more filtration, chemical processes to break down any remaining pollution, and final disinfection. And on regulation, the county abides by the Clean Water Plan, which is the primary federal law enacted in 1972, which is responsible for regulating water quality and establish water quality goals for surface water in the United States. EPA delegates authority to the Washington State Department of Ecology to regulate and administer permits for wastewater treatment plants. And wastewater treatment plants have a National Pollution Discharge Elimination System permits, which prescribe effluent water quality parameter limits, such as 5-day biochemical oxygen demand, total suspended solids, pH, fecal coliform bacteria, and total residue chlorine. These permits also identify required monitoring and reporting, and identify flow or loading triggers for planning for maintaining capacity when specific design criteria are reached. It's important to note that discharge limits continue to evolve. For example, current regulations do not require the removal of nitrogen. Regulations to limit nitrogen from treatment plants discharging to the Puget Sound are being considered by ecology. The specifics of any pollutant potential effluent requirements are currently unknown. Throughout the county, there are also other compliance measures that are used, such as water quality trading, as long as they meet water quality standard requirements and objectives, and the Federal Clean Water Act. And when considering all of this wastewater treatment, the Clean Water Plan is looking at actions that seek to explore the following list of questions. What treatment plant and wet weather facility investments should be made? How do higher levels of treatment impact water quality? What additional treatment capacity is needed to prepare for anticipated growth, and when is it needed? How should King County prepare for advances in small-scale decentralized treatment? And how do higher levels of treatment contribute to recycled water availability? We are exploring this area because we know our system. Both the conveyance and treatment systems are facing capacity constraints that would require investments in infrastructure. There's potential that regulations will be changing both in the near term and over the 40-year planning horizon. And also treatment technologies and approaches continue to evolve. And with all that background, I'm sure some of you may have some questions for our team. So now I'm going to pass it over to Darcy to facilitate the Q&A for this portion of the workshop.
Thanks very much. And I've just received a message that we're going to need just a quick pause here to do a tiny bit of troubleshooting on our Spanish interpretation channel. So we're just going to pause for just a moment. We see we have lots of great questions that have come into the Q&A box, so we really appreciate that. And of course, you all, as you think of more questions, can feel free to continue to include those. So I'm seeing our interpreters, Pablo and Claudia, if you could switch now. That would address the issue. Okay, thanks very much again for those of you who have typed in questions. We will now go through our questions and get some answers to those for you. Our first question is, how do you plan to address gray water waste that is dumped directly into the waters from houseboats and other sources where humans live and work on the water? Elizabeth Lowell, would you like to help us out with a response to this question?
Sure, yeah, thanks, Darcy. And I will start, and then I'm going to pass it over to Megan as well. So a great question. You're kind of teeing us up for the section later on in the program when we get into pollution source control. Short answer is those sources of bacteria primarily are being considered in the pollution identification and correction program that the county runs, the PIC program. So I will kick that over to Megan to talk a little bit more about that.
Yeah, definitely. So I am Megan Jackson. I work for Public Health, Seattle and King County, and am part of the PIC program that Elizabeth was mentioning. When we're talking about vessel discharges to marine waters, there's definitely a lot to consider here with both the black water discharges and the gray water discharges. The Puget Sound area has made amazing advancements with the no discharge zone of really limiting black water discharges to our water bodies. We have seen a significant impact from this. And one of the benefits from this is that dumping stations have become more and more common and more advertised. And so we're seeing more and more upgrades to dumping stations and an encouragement that boaters and people who are recreationally on the water are continuing to use and increasing their use of these dumping stations. Which I think is one of the ways that this no discharge zone that ecology has put into place is impacting not just black water, but also gray water. There are also federal and state regulations regarding the pollution that can come with gray water discharges to marine waters, where people who are using vessels are required to be very intentional about the types of discharges that are allowed. And so as part of the PIC program, we will be, and we are focusing on specific areas where higher levels of fecal coliform and bacterial pollution have been identified. And if vessel discharges are identified as a significant source of fecal pollution in those areas, we'll also be including some of these options for addressing this pollution in our outreach and making sure that those rules are being complied with.
Great, thanks very much. Our next question is on total organic carbon, or TOC. It says total organic carbon is a monitoring requirement in the Washington Department of Ecology's draft general permit, but I didn't see this in the list of parameters that the Clean Water Plan is considering. Is total organic carbon being considered as a potential contaminant? We will hand this question to Ian McKelvey.
Hi, yes, thanks for that question. It's true we didn't include that on our list. Our list wasn't meant to be comprehensive of all of the pollutants in our region. We selected that list to try to be representative of the pollutants that are impactful to water quality in our region, and also things that would be changed by some of the actions that we're looking at. So while it's not on the list, we did think that the list that we had there captured some of the same impacts and outcomes that you would expect to see on water quality in the region. So that's why we didn't include it there.
Next question. Will the financial estimates assume any federal or state funding over the planning period? Steve, would you like to answer that one?
Yeah, thank you, Darcy. Good morning, everyone. Steve Tolsman. So what we're providing for you today, and Sonia broke it down, the elements of it is the cost estimates for these actions. So where we're at the point in the process is getting that good understanding of what it costs to make the investments. As far as the grants from state and federal sources, we will look at that when we move into our strategies, and then certainly our preferred strategy and financing plan is where we would look at that. I will note, if you look historically over the past several decades, those sources of state and federal funding and grants has been low relative to the costs that we see to make these investments. So that would be an assumption we would carry into that yes, some of those would be available, but the expectation would be that the assumption would likely be that they wouldn't be a substantial amount of the funding needed.
Thank you. Next question about the long-term revenue generation from recycled water in the context of potential competition and/or new collaborative models with water supply utilities like SPU and Cascade Water Alliance. Steve, would you like to answer that one as well?
Yeah, I'm going to get started and then pass off to my colleague, Jackie Klug. I'll get started from the Clean Water Plan context setting. The Clean Water Plan is looking at recycled water as a wastewater management tool. So you'll hear later today about several of our actions that include recycled water, for example, in decentralized treatment or in advanced treatment, where the approach we're taking to wastewater treatment results in a recycled water product, and therefore we're looking to utilize that product. But the driver of that from the Clean Water Plan perspective is not to provide a water supply source because some need has been identified there. And Jackie, if you're available, I'd like to ask you to just comment some on the coordination the county does with the water suppliers.
Sure. My name is Jackie Klug, and I'm a project manager in our recycled water program for King County Wastewater Treatment Division. And so Steve is right. We have been coordinating with the drinking water systems regionally for the past few years, really to address any concerns that they have moving forward with our existing program, as well as in the long term about potential impacts to revenue loss from bringing in a new water supply into the marketplace, as well as any other concerns that they have.
Thank you. Next question, how are microfibers removed or treated from water? I'm concerned about, quote, nano-sized stuff that is too small to trap and take out. Tiffany, would you like to provide our response?
Yeah, I'll kick it off and then turn it over to one of our subject matter experts, Bryce, to elaborate. So our current processes aren't designed specifically to remove nanoparticles. So it's actually one of the reasons that we do have our pollution source control and product stewardship decision area. So we'll talk a little bit more about that later on today as well. But when we look at our existing processes, they do a good job to remove what they're designed to remove, but only limited efficiency with nanoparticles. But I know there is some removal that's achieved, so I wanted to pass it off to Bryce, maybe to elaborate on some of that.
Sure, thanks. Good morning. My name's Bryce Figdor. I'm a senior wastewater process engineer with HDR, supporting the team here. And yeah, micro and nanoplastics removal, very important topic. And despite the pretty small particle size of micro and nanotype plastics, they're pretty efficiently removed in conventional wastewater treatment by means including just physical removal, sorption or attachment to solids, and subsequent settling and removal of those solids, and at even higher levels of treatment by filtration. So between those means, conventional wastewater treatment has pretty good micro and nanoparticle removal efficiencies, greater than 90%, not 100%. So of course, there's still some microplastics discharge, but all in all, we get pretty good removal, and solids removal is a good indicator of the extent of the removal of those types of materials. So I can send some additional literature to the questioner if that's useful as well.
Thank you. The next question is why use a clarifier system versus membrane filtration as is done in the Brightwater plant? Tiffany or Steve, would you like to provide a response?
Yeah, I'll start there. So our South Plant and West Point treatment plants were designed and built in the early 60s. And at the time, clarifiers was a standard technology to use for separating the solids and liquids. So that's one of the reasons that technology is used there versus membranes. The other thing I'd mention is that membranes definitely have benefits, but they also have their challenges. And so just in general, when we look at wastewater treatment and the possible different processes we can use, there are processes that work better in some places than others. And so really it becomes site specific around what we're trying to achieve and maybe what the site constraints are that helps to direct what type of technology we might use for the treatment processes.
Thank you. Next question, is the county using fecal coliform or have you switched to E. coli? Ian, would you like to provide a response on this one?
Hi, yeah, we're currently using fecal coliform. That's what's in the permits with the Department of Ecology. So that's what that's the bacteria, representative bacteria that we used for the when we looked at the actions for the Clean Water Plan.
Thanks. Next question, what are some examples of possible decentralized treatment options? Tiffany, would you like to provide a response to this?
Sure. I'd actually like to, I'm going to punt the response just a little bit in terms of we have a whole section where we're going to speak to a lot of the decentralized options that the plan has looked for. So maybe just a teaser to stick around for a little bit, and then after the break, we'll get into the details of that answer.
Can you explain breaking down nitrogen? Is the question. Tiffany?
Yeah, why don't I pull in, let's see if Aaron Jacobson would be willing to jump in on a little bit around how breaking down nitrogen or how the nitrogen removal process works.
Hi, I'm Aaron Jacobson with ammonia to nitrogen gas. That's sort of the goal with removing nitrogen, is to have it leave as N2 gas, which makes up 80% of the atmosphere. So that's largely what removal of nitrogen is, or breaking it down.
Thank you. Question, what is the cost for side stream for nutrient removal? Aaron, would you like to provide a response?
Sure. So as part of that nitrogen removal study, we did look at side stream treatment for the 3 regional treatment plants, and the total project costs was, we had a large cost estimate range for that study, but it was on the order of tens of millions up to hundreds of millions of dollars for each plant.
Thank you. Question is, I assume that enhanced technology options could be identified for each treatment plant and that they might vary based on the base technology used at the plant or facility. Tiffany, would you like to provide a response?
Sure, I'll start, and then I might actually punt to Aaron again to maybe just in general elaborate. I mean, I think one of the things here, similar to the question on membranes, is that different technologies work well in different situations. And again, site constraints, the type of wastewater it receives, and other things. So we definitely, when we look at what enhanced technologies we can use, we consider the range that's out there and then start to look at what may be most applicable. So we do have an action that we'll talk about in a little bit that does look at advanced technology. Also, some of it is also depending on what you're trying to achieve as far as effluent quality and where that effluent may be going. So Aaron, I didn't know if you had in general just a little bit more that you could add just around different types maybe of advanced or enhanced technologies for wastewater.
Well, looking at the actions that we had in the Clean Water Plan draft so far, it is looking at filtration. So MBRs would be advanced, but then also different methods to creating direct potable water that could be either used for surface water makeup or potable reuse. And those get into a lot of different steps, like many steps. There's one option, reverse osmosis, which doesn't really fit for our location, where you'd have to discharge a brine somewhere. But the other steps involve ozonation, activated carbon filtration, and some additional steps beyond even MBRs. So there's sort of a range of technologies out there that go beyond filtration with MBRs and treatment with MBRs. That some of which are covered, will be covered in the Clean Water Plan as it comes out.
Thank you. We have time for just a couple more questions. As a reminder, we do have 3 more Q&A sessions in this workshop. So if we don't have time to get to your question right now, we may be able to get to it later, or it may be answered in the later presentations. Next question is, you have a range of estimates from low to 150%. What is that 150% of what?
Yeah, so good question there. So when we're providing the range of estimates, the low to the 150% reflects the accuracy range of those estimates. So when we're looking here at our long-term plan and looking at planning cost estimates that may occur over the 40-year planning period, we want to reflect the temporal nature as well as some of the uncertainty that exists in how the projects or programs would be implemented, as well as change conditions over the course of 40 years. So we provide a range, an accuracy range that reflects some of that long-range planning and some of those uncertainties.
Temperature also wasn't included on the list of parameters considered by the plan. There are many temperature impaired streams throughout the Sound and in the county, which is an important consideration for salmon recovery. Is there a reason temperature wasn't included here? Ian, would you like to provide a response?
Yeah, thanks for that one. Yes, temperature is an important consideration, as you mentioned, for salmon recovery. But it's another example of a water quality attribute that the county, the wastewater system, because it doesn't discharge to these streams, it's not something WTD has a major impact on. So it wasn't one that the actions were really going to have a big impact on. There is possibility for stormwater flows to have some impact to that. We were looking at some stormwater actions, and so that is in some ways covered by our looking at the flow reductions that would come from if we're doing more stormwater management, if that results in peak flow reductions. So.
And we have time for one more question before we're going to need to move on. The question is there any way to estimate what state and federal funding will be in advance? Steve, would you like to answer?
Yeah, thank you, Darcy. Good morning again, everyone. Steve Tolzman. So the short answer would be I'd follow up with my comments a little bit ago that we would look at the historical funding that's been available from state and federal resources. So we would look at that, the trends over the past few decades. I'll note just a couple things for the current context. That money can come in grants or it can come in loans. So loans, of course, you pay back. It's a very current aspect about our climate, but it's been in play for 5 or more years now. Interest rates are so low in totality that the federal loans are, frankly, it makes them, the federal and state loans aren't that competitive to other bond sources. And then grants, generally just grants as far as gifted money has been pretty hard to come by. So again, we will take a look at all that, and when we put together this strategies, reflect what we think would be a appropriate estimate of state and federal grants towards that.
Wonderful. Want to thank everyone for all the questions you typed in so far. We are going to need to move on. Several of the questions that are currently in the box will be discussed during some of the actions presentations. So you can let us know if you still have questions about them after you hear, but maybe those will be illuminating. Okay, we are going to move on to our next presentation now. So I will hand it over to Tiffany. Next slide, please. For our regional wastewater treatment actions, as you can see where we are on the agenda. And then after Tiffany's presentation, we'll have our next Q&A session. Next slide.
Great. Thank you, Darcy. And good morning again, everyone. I want to welcome you again and thank you for your time and being here today. Again, I'm Tiffany Knapp from the King County Wastewater Treatment Division, and I am one of the program managers for the Clean Water Plan. And as Darcy mentioned, we're shifting into our first segment where we will be talking about actions from the wastewater treatment decision area and specifically the regional wastewater treatment actions. So as you heard from Sonia just a little bit ago, in this workshop today, we are exploring some of the Clean Water Plan actions in order to provide a foundational understanding and to serve as the basis for an upcoming regional discussion on the choices and opportunities that the county is facing for the regional wastewater system and water quality. Ultimately, the plan is looking to address our core planning question around what's the most appropriate path to ensure we direct the right public investments to the right actions at the right time for the best water quality outcomes. So the actions are conceptual programs or sets of projects that address one of the decision areas that the plan needs to consider. And as Sonia mentioned, they will become building blocks that will be shaped and formed and combined in different ways to form the complete water quality investment approaches, or what we're calling strategies later in the planning process. So we have nearly 35 actions from 7 different decision areas, and those are what are shown on your screen there. And this first segment of the actions, again, is about our wastewater treatment decision area, which considers both how to provide capacity for population growth and the level of wastewater treatment. So the Clean Water Plan has about 10 different wastewater treatment actions, and these actions can generally be characterized broadly into the regional treatment actions and decentralized or smaller scale treatment actions. So I'll be speaking to the 5 regional wastewater treatment actions, and then in the next segment after the break, we'll talk about the decentralized wastewater treatment actions. So within the regional treatment actions, we're exploring a range of treatment levels. All of the actions include expanding treatment capacity to handle population growth. And then we look from there around increasing the level of treatment. So as Sonia mentioned, the regional wastewater system, the regional treatment plants currently provide a secondary level of treatment. So the first action explores maintaining this level of treatment. The next 3 actions explore an increased level of treatment. And one of the reasons that we're exploring an increased treatment level is due to potential changes in regulations that would limit the amount of nitrogen in treated wastewater effluent. And the specifics of those potential effluent requirements aren't currently known. So through the Clean Water Plan, we want to understand the scale of potential impacts on the regional wastewater system, on the county, and on our ratepayers for several potential ways these regulations could be implemented. So like all of our actions in the Clean Water Plan, these are representative concepts, and they don't prescribe the level of treatment in which the county may ultimately invest. We've also heard interest and input from others in the region about that have asked us to explore what reducing or removing some of our discharge from Puget Sound would look like. So the advanced treatment action explores this concept. And then finally, we have the water quality trading program action, which explores an alternate, potentially less infrastructure heavy method for nitrogen reduction. So I'll be presenting an overview of the characterization of each of these forward-looking conceptual programs over the 40-year planning horizon. And there are more details, as you see in that box on the right there, more details than I'll have time to present today. And those details can be found in section 4 of the document, Actions Characterizing Water Quality Investment Options. And that document is on the Clean Water Plan website, and also a link was provided in your reminder emails about this webinar. So jumping into our first action, we expect that population will continue to grow over the next 40 years. And so this action would implement a phased treatment capacity expansion program and provides us an understanding of what would be needed at West Point, South Plant, and Brightwater, our 3 regional plants, in order to provide capacity for that increased population while we maintain the current secondary level of treatment. So you can see in the photo at the top there, that's our West Point treatment plant. West Point is a plant that's very site space limited, and there's really very little space to expand it. So to provide additional process units for capacity, one consideration is that by the end of the planning period, the end of the 40 years, this site would be completely built out. In addition, due to its location within Discovery Park and near the edge of Puget Sound, construction impacts at West Point, even just for expansion for capacity, are not insignificant. They would be pretty major construction. The other photos on this slide, the one there in the middle right is South Plant, and then the one on the bottom is Brightwater. So there is space that exists on those sites for capacity expansion, but we would pretty much be using most of that up through expanding for capacity. So when we look at the water quality parameters impacted by this action, we see that existing treatment processes are very good at removing the substances that they are designed to remove, which is generally bacteria, solids, and organics. But they're not designed to remove other substances like nitrogen or other compounds. So there's limited, even though we may receive some, there's limited removal of these other compounds through this type of treatment. I should also note that our regional treatment plants discharge to Puget Sound. So any changes in the parameters or any removal for all of these regional wastewater treatment actions, the treated wastewater effluent is only going to impact the sound, not other lakes or rivers in the region. Conceptual program planning estimates to provide capacity for population growth at the current level of treatment is about $1 to $2 billion over the 40-year planning period, with about $3 to $8 billion in operations and maintenance. And this action doesn't require any changes to any of our current partnerships or collaborations in order to implement. So these next 3 actions look at increasing the level of treatment at the 3 regional treatment plants. All of these actions would also include expansions for populations similar to that first action that I just spoke to. So the Washington State Department of Ecology has been indicating their intention to regulate wastewater dischargers within the Puget Sound region for nitrogen. And as I mentioned, the specific regulatory mechanisms and permit effluent requirements haven't been determined. So the Clean Water Plan is exploring several representations of ways to reduce nitrogen into Puget Sound. The next two actions are two of those conceptual representations of what reducing nitrogen in the King County Regional Treatment Plant discharge might entail for those regional plants. So this first action, this first nitrogen reduction action, explores removing nitrogen to the same level at all three regional treatment plants. And to do so would require a significant amount of new infrastructure. So for some of the plants, this includes very large construction projects where we would need to change the existing basins so that they are configured and operate differently in order to actually achieve nitrogen removal. In the case of West Point, I just talked about how site constrained that physical location is. And so there's not room to add more basins and structures. So what we would actually have to do there is decrease the amount of flow that is allowed to flow to West Point and that we could treat there. This is sometimes called derating a treatment plant in order to reconfigure the existing basins to treat for nitrogen. So we would then need to build a new fourth regional treatment plant that could take the flow that then is not going to West Point. And this new treatment plant would have to take a little over half the flow that's currently going to West Point. And for those of you that maybe are a little more familiar with our system, the size of this plant is essentially about 3 times the size of Brightwater in terms of flow. So due to the existing configuration of our existing pipes that move wastewater from the service area to West Point, and the amount of flow that we would need to capture and carry to the fourth new regional plant, the new plant would likely need to be located north of downtown Seattle, but not too far away from West Point. So the map at the right there shows conceptually in blue, that kind of blue circle, the potential area where a new treatment plant could be located, with the orange boxes locations where flow could be diverted from the existing conveyance pipes to the new treatment plant. So in addition to adding nitrogen removal at Brightwater and South Plant, or in addition to building a new treatment plant, removing nitrogen at Brightwater and South Plant would also really reduce the space available for any future capacity or additional solids or liquid treatment. So from a water quality perspective, the amount of nitrogen in the treated wastewater effluent would decrease. That's the goal of this action. But once again, nitrogen removal processes are designed and operated specifically for nitrogen reduction, so there'd be little removal of other substances. The conceptual program planning estimate to provide nitrogen reduction as well as capacity for population growth over the 40 years is on the magnitude of $9 to $22 billion, again, over the 40-year period. And most of this cost is in the building of that fourth new regional treatment plant and in modifying West Point to achieve nitrogen removal. Operations and maintenance would account for about $4 to $10 billion over the 40 years. And it's also notable that these processes that remove nitrogen from wastewater also release greenhouse gases in their emissions. So Aaron spoke to that in our last Q&A there about the nitrogen removal processes. So they actually do release greenhouse gases, so our greenhouse gas emissions would increase. And they're also very energy intensive, so there would be a substantial increase in energy use to run these new processes. And then we also know there'd be very much so impacts and challenges to siting a new large treatment plant in a very urban area. On the flip side, this also could create some opportunities for increased use of recycled water. So I mentioned that the specific regulatory mechanisms around nitrogen are not determined yet. So the Clean Water Plan is also exploring another representation of reducing nitrogen in the treated wastewater effluent. So this is the King County Utility-Wide Nitrogen Reduction Action. And this isn't a different technology, but instead it's a different way regulations could be applied. So this is sometimes referred to as a bubble permit. In this action, each plant is still reducing nitrogen, but instead of all 3 plants reducing to the same concentration, some of the plants would remove more nitrogen and some plants less. So overall, that means that the utility is removing a similar amount of nitrogen to the previous action that I just spoke to. So with the clean water plan here, this action is assuming that nitrogen reduction at South Plant and Brightwater would be to a lower level than what was shown in the previous action. And then that West Point would provide more limited nitrogen removal with a side stream treatment process that could fit on the existing treatment plant site. Because more basins would be needed at Brightwater to remove that more nitrogen, it would likely require expanding the existing Brightwater site slightly. And similar to the last action, but even more so, even less space would be available for future expansion or for additional solids or liquid treatment at all the treatment plants. From a water quality perspective, we are looking at similar impacts to the previous action. This action does remove slightly less nitrogen overall compared to the previous action. And then like the other one, there is very little removal of other substances or compounds when we're just targeting nitrogen. The conceptual program planning estimate to provide nitrogen reduction and capacity for population growth is on the order of magnitude of 4 to 9 billion over the 40-year planning period, and also 4 to 9 billion for operations and maintenance. And then other potential impacts are similar with a substantial increase in energy usage and also in greenhouse gas emissions. And then there's also the potential for some community impacts around Brightwater due to the site expansion. So for this next action, something we've heard from people is an interest in exploring what reducing our discharge to Puget Sound would look like. In addition, as we've seen with those previous 2 actions, the order of magnitude of nitrogen reduction upgrades and improvements would likely be pretty significant. So if we're looking at upgrades to the treatment plants of this scale, and we're thinking about the next 40 years, it also makes sense to consider and introduce into the conversation the concept of reducing discharge to Puget Sound and of more advanced treatment processes. To represent this concept, this action assumes that South Plant would be upgraded to an advanced treatment facility and then no longer send treated water to Puget Sound. And I'll note that a treatment program of this scale could be implemented in a phased manner over the 40-year planning horizon, or only a portion of the program could be implemented during the 40-year planning horizon. So conceptually, what this looks like is adding advanced treatment at South Plant. We would need additional land near the South Plant site for the advanced treatment processes. And then we'd also assume that Brightwater would be upgraded to reduce nitrogen, and that all 3 plants, like all the other actions, would include capacity improvements to accommodate population growth over the 40 years. So in order to have a measurable reduction in discharge to Puget Sound, we would need to have a reliable year-round reuse of a very large volume of treated water. So this would likely lead to using recycled water for direct potable reuse or for surface water augmentation. And I'll note that although advanced treatment processes have been implemented at many locations in the country and in the world, they are new for this area, and they have also not been implemented at this scale in the United States. So we definitely need to have further study and testing before we are able to implement the concepts in this action. Reducing discharge to Puget Sound decreases the overall nitrogen discharged from the county's treatment plants to a similar level as the utility-wide nitrogen reduction approach. And in addition to that, it also does remove the some other substances that would no longer then go to Puget Sound. So some of these that the secondary nitrogen removal processes don't remove. Conceptual program planning estimate for this action to provide capacity for population growth and advanced treatment is on the order of magnitude of 7 to 18 billion, again, over the 40-year planning period, with 4 to 11 billion for operations and maintenance. So similar to the nitrogen removal processes, advanced treatment processes do require substantially more energy than the current treatment processes, and we also would see higher greenhouse gas emissions. And then as mentioned, implementing this action and the scale and the type of year-round reuse of treated water would be something new for this region and would definitely require the collaboration and offer the opportunity for partnerships to make use of that treated water. For this last regional treatment related action, I wanted to circle back to nitrogen reduction. And this action is one of the other concepts the Clean Water Plan is exploring as an alternate method that may exist for Clean Water Act compliance for nitrogen in Puget Sound. So due to the tough decisions that need to be made through this plan and its long-term nature, it makes sense to also think about and bring into the conversation approaches that may be less infrastructure heavy than the previous actions I was just speaking to. So water quality trading is a compliance mechanism that's been used in other parts of the country. And what this is, the concept is that point sources that are within the same watershed, so for instance, wastewater treatment plants that discharge to Puget Sound, would participate in a water quality trading program by either reducing effluent nitrogen below the requirements and then creating credits that they can sell to other dischargers, or by buying credits generated by other point sources or non-point sources, such as runoff from agriculture, or by a combination of buying credits and implementing some of the infrastructure upgrades that I spoke to in the other actions. So this type of trading can be done through direct one-to-one trading or through a framework where many entities participate all together. And in this region, the applicability and feasibility of water quality trading is still very much in the early stages, and a water quality credit trading framework for Puget Sound would need to be established. So this is something that would take working with the Department of Ecology, with other point source dischargers and others to develop that program and determine the different trading processes. And based on precedents of other trading programs that have been set up in other parts of the country, this is something that would require a multi-year effort to put into place. So to be functional and approved as a viable approach, though, by definition, water quality trading programs achieve equivalent or better water quality outcomes in terms of nitrogen's impact on Puget Sound. And then also with such a program, there is the potential to be able to focus on areas within Puget Sound that are most affected and also to potentially achieve other water quality and habitat benefits along with nitrogen removal. So those are the actions that the Clean Water Plan is looking at for our regional wastewater treatment. And then pulling together some of the overall takeaways on these actions on these next two slides. When considering the removal of the various water quality parameters, the existing level of treatment is very good at removing our regulated parameters that treatment is designed for. And then similarly, when looking at nitrogen reduction treatment processes, they are effective at removing nitrogen, but have minimal impact on most other water quality parameters. And then finally, reducing treated water discharge to Puget Sound from South Treatment Plant does reduce all water quality parameters and also reduces nitrogen to a similar level as the utility-wide approach. In addition to reducing the water quality parameters, it is important to recognize that there are increases in greenhouse gas and energy emissions with these increased treatment levels. So there are other impacts beyond what we achieve through the water quality parameter reductions. And then also, as I noted, these actions really do include significant investments in new infrastructure, and especially in areas where there would need to be new treatment facilities. The construction of this infrastructure does have the potential to have impact on surrounding neighborhoods. So I also wanted to talk a little bit about as the Clean Water Plan has developed and characterized the actions, we've also looked at where opportunities may exist to incorporate equity into the actions. So there are several examples on this slide, but there's also more information that can be found in that actions document, the actions characterizing water quality investment options in section 4.2. So for the regional treatment actions, one equity opportunity exists to be responsive to interests and priorities of historically marginalized communities during the siting and design and construction of the large capital projects, large infrastructure. So for example, incorporating facility amenities to provide green space or education opportunities at the facility, especially if these are located in a populated or a residential area. Although some existing county programs and processes are in place, realizing this opportunity may require the county programs, processes, or resources to increase and there to be new processes in place. Another equity opportunity that may exist in supporting entrepreneurship and workforce development, as well as helping small businesses grow through equitable processes during the procurement and contracting for facility improvements. So this could include contracting and job opportunities during construction of new facilities and new treatment upgrades at existing facilities. And there are county programs and processes that are in place to help meet these opportunities. Finally, inclusion of community considerations in program development. For example, there may be opportunities to provide the option for access to recycled water to priority communities or users first. And realization of any of these equity opportunities really depends on the flexibility in siting and technical feasibility, the ability to scale or prioritize projects and programs by neighborhood, and in community engagement to truly understand business and household interests. So these are some initially identified potential equity opportunities, again, while we developed the actions. We will continue to further consider equity opportunities as well as impacts and other considerations as we continue in the Clean Water Plan process and the actions are combined into strategies in the next step of the process. And then also consistent with existing county equity practices, equity opportunities will also continue to be assessed and incorporated throughout the implementation of the projects and programs that are ultimately identified in the final plan. So finally, even though with what we're looking at here with our actions, we've been looking specifically within the wastewater treatment decision area, I want to acknowledge that these regional treatment actions, they have connections to other decision areas and other actions. And so for example, again, we'll talk a little more about decentralized treatment actions in the next segment. But these decentralized actions are another approach to potentially managing capacity due to growth in the region. I also mentioned that the regional treatment actions have the potential to add really significant infrastructure and new infrastructure to the wastewater treatment system, which means ultimately then more infrastructure to manage, which is then a connection to the aging sewer systems, natural disasters, and climate change, or what we also call the asset management decision area. And then how we're able to recover and recycle resources from wastewater, or the resource recovery decision area is also interrelated with the core wastewater treatment processes and the level of treatment. And then finally, looking at preventing pollutants from entering the wastewater in the first place has the potential to be more efficient or effective than working to treat pollutants at the wastewater treatment plants after they've entered the system. So this decision area, the pollution source control and product stewardship, is another area that we'll hear more about later today as well. So with that, I'd like to turn it back over to Darcy to facilitate our question and answer portion for this part of the workshop.
Thank you, Tiffany. Lots of folks have been typing questions into the Q&A. We appreciate that, and we will begin to go through some of those now. First question, have you looked to see whether the projected quantity of reclaimed water can be inserted back into the environment? Ian, would you like to provide a response?
Hi, yeah, we'll be talking more about recycled water and the centralized treatment actions as well. But the answer is that developing the actions, we've gotten to the point of identifying opportunities for recycled water, and provided some scale of what we think is possible, that recycled water could be beneficially used, but definitely there will need to be some further study and analysis needed before any particular or specific end use is defined of where exactly that water is going.
Thank you. What are the sources of nitrogen? Is it all human waste? Tiffany?
Human waste is definitely a large component of that, and I'm looking to see if Ian or others want to join in with how we also looked at that.
Yeah, I can help out. So yeah, human waste is the vast majority of where the nitrogen in wastewater comes from, but there's also other sources, food waste that ends up in going down people's drains or soaps and detergents. But yeah, it's the vast majority comes from human waste.
Good. Next question. 4 to 9 billion for operations and maintenance over how many years? This is not yearly, of course, so I assume these figures are over the 40-year period, but want to check.
That is correct. So the figures we're showing are over the 40-year period. Again, we're looking to understand an order of magnitude for these different actions and these different options. So we are looking over the 40-year period for that.
If the water from the South Plant would not be sent to Puget Sound anymore, what happens after the advanced treatment? Tiffany, would you like to provide a response on that one?
Yeah, I'll start with a response and then maybe pass it over to Steve or see if he wants to pass it to one of our recycled water folks. So as I noted, there is a lot of water that would be available for reuse, and so it would need some place other than Puget Sound if we're looking to remove that flow from Puget Sound. So we would be looking at a direct potable reuse or a surface water augmentation type use of that after it's treated to an advanced treatment level. And Steve, do you want to expand or pull in one of our recycled water people?
Yeah, I just wanted to first note before passing off to Jackie Klug, I wanted to note this is, I think this action is significant in showing that the Clean Water Plan is trying to look far ahead and look outside of the box here. And our engineers can also speak to this, but this level, in order to get that measurable reduction in Puget Sound discharge, would require an advanced treatment facility on the scale of, I think, larger than anything currently in place on the globe. We are trying to look ahead with this very much. Should this be part of our long-term, or could this fit in our long term? So it's very much advanced thinking in that way. And then maybe Jackie, if you could speak to kind of just where the rules are currently with respect to this, because that measurable discharge would probably require, given the amount of rain falling here in our region during the winter, would require some sort of potable reuse aspect of this. And Jackie, if you could just comment on where the state is with rules on that, that would be fantastic.
Sure. So currently the Washington state doesn't or has a pathway that if a utility wanted to pursue treating wastewater to drinking water standard, that there's a pathway where that could be approved, but there's no such projects developed, and it would require a special petition to the State Board of Health. There are a lot of states in the United States that have developed regulations on direct potable reuse. And so it's being looked at a pretty large scale. And most of the municipalities in Southern California are in some stage of looking at a feasibility of using their wastewater to bring into their drinking water systems. So I think we have a lot of examples to look from nationally, but we would have to develop and negotiate with the state as to what the rule framework would look like in Washington state. And I think one of the challenges Steve was saying is just in the Northwest, a lot of places recycled water you have a year-round demand for like irrigation, but we don't, since we get so much rain in the winter months.
Great. We've had a couple of questions related to greenhouse gas. The first question is there an option to reduce greenhouse gas? Aaron, would you like to respond to that one?
Hi, sure. So at least in terms of the nitrogen removal process or processes that are available, there's different ways that greenhouse gas emissions are generated. We look at generation through additional energy use. Nitrogen removal takes additional electricity, and emissions are created from electricity generation. In addition, there's additional chemicals that are typically required to make the process work. And those chemicals, the generation of those chemicals create greenhouse gas emissions. And then a third major way is that the nitrogen removal process, which is done largely with biological nitrogen removal, so within an activated sludge treatment, similar to our secondary treatment, the biological process for removing nitrogen can also produce nitrous oxide, which is a powerful greenhouse gas. And the technologies that are out there are available. Each one has a different amount of nitrous oxide that's produced, but the amount is really not well known, and the processes are very complicated. So how we would reduce greenhouse gas emissions from a particular nitrogen removal technology, we will be having to look into more to better understand what options there are, what options have low nitrous oxide emissions, and whether or not those technologies fit for our regional treatment plant for the retrofit within the existing treatment plants.
Thank you. Another question related to greenhouse gas. For increases in greenhouse gas emissions with advanced treatment, wherein the reductions in treatment for potable water taken into account in the reduction in greenhouse gas emissions from that avoided drinking water treatment? Ian, would you like to provide a response?
Yeah, thank you. We didn't include the avoided emissions from potable water treatment. Some of that was we were looking at greenhouse gas emissions for all of these actions from, we didn't look beyond what King County does into how the behavior of other entities in the region would be changed by these. But this one specifically, like Tiffany mentioned, the advanced treatment action does create a recycled water use. How that water gets used isn't 100% nailed down, so didn't seem appropriate to presume exactly how that would affect how the potable water utilities in our region behave.
Thank you. How much of the cost would other municipalities bear? City of Seattle, Port of Seattle, Duwash Industries, etc. Steve, would you like to provide a response?
Absolutely. Yeah, with respect to costs, and then when we move into financing, as we do that later in the planning process, excuse me, we want to look carefully at how those costs are allocated. Of course, there's utility fees, which are currently largely the funding comes from utility fees. There's other revenue mechanisms out there for public services that could be looked at as well. So that'll be looked at. And in addition, I would note, in addition to those those public sector entities, or those entities that were listed there on the slides or in the question, we plan to look at the benefits and burdens across our population of this cost, and particularly from an equity and social justice standpoint and an affordability standpoint. How does this play out as far as those costs translated into actual utility bills, or whatever funding mechanism would be used to get the funds for these types of investments?
Thank you. Next, I understand that PFOAs are not removed from wastewater and would want to be sure this would not become an unwelcome constituent in potable water consumers would be drinking as a human health concern. This goes for using reclaimed water in areas where it would percolate into a drinking water aquifer. Ian, would you like to provide a response?
Yeah, actually, to this one, there's another question about addressing pharmaceuticals in advanced treatment. It's kind of the same answer for both of those questions. Like Tiffany was saying, the advanced treatment action is the action we looked at that's looking at broadly, removing pollutants beyond what is currently regulated, or nitrogen, to the broader suite of contaminants of emerging concern. So things like PFOAs and pharmaceuticals would be captured under that umbrella. So the specific removal amounts, or whether that's the appropriate removal for an end use, would need further study. But in general, that was the intent of that action, was if we are interested in removing CECs in our region, what would we have to do? We'd have to do something on that level.
Thank you. Have you assessed what impacts the existing WTD system has had on underprivileged populations? Nicole?
Hi everyone, Nicole Smith. I'm a planner with the Wastewater Treatment Division, and the planning team is using the King County's Equity and Social Justice Strategic Plan to establish a baseline of equity in King County. And in the future, as the planning process moves into strategies, we will be evaluating the positive and negative impacts of these strategies. So more information to come on that in the future.
Thank you.
And I did just want to open it up to Elizabeth Lowell in case she has any additions.
No, I think you covered that pretty well. As Nicole mentioned, there's some things coming when we look into strategies, and that's looking at evaluating, things like affordability, impacts to water bodies and who uses those water bodies, how they use them. So a lot of that is going to be definitely a part of the Clean Water Plan process still to come.
Great. Next question. What about going vertical and using a roof that could be a public benefit like sports fields? And in all these cases, why didn't you include advanced treatments that would address other pollutants? Tiffany?
Yeah, so I think we addressed the second question a little more, Ian's response there. If it's more specifically each of the actions, the nitrogen ones, we didn't include advanced treatment because we're trying to more specifically look at the specific scenarios around nitrogen. And then about going vertical and using a roof that could be a public benefit like a sports field, that's definitely something that we would continue to consider as these conceptual programs and projects actually would move on to becoming true projects that would be designed. So looking at how we can incorporate green space and how we can incorporate those kind of needs of the community is something that we do look at when we get more towards an implementation situation. And I think if part of the question also is in kind of going vertical and trying to maximize the use of space, that's also something that we do and look at, particularly on the West Point site. That treatment plant already is in the processes are actually kind of in multiple layers there. It's almost a two-story treatment site and treatment plant, even though you wouldn't guess from the outside.
Great, thank you. To the operations and maintenance question, are the cost estimate ranges projected for the action alternatives in addition to the operations and maintenance already needed under the existing levels needed? Or would that number replace the 1 to 2 billion already needed over 40 years for operations and maintenance? Tiffany?
Yeah, so each of the actions is essentially standalone in how we're looking at them. So it's not in addition to the 1 to 2 billion for the existing level of treatment. It's the all-encompassing number to do that action. So if it's a nitrogen removal action, the nitrogen removal, the capacity improvements needed, and then to operate those processes over the 40 years. So it is standalone.
Great, thank you. What is the impact of the new storage tunnel being built by SPU on the West Point plant with regard to nitrogen, et cetera? Tiffany?
Yeah, that storage tunnel helps to capture combined sewage, combined wastewater and stormwater during storm events, and then that's sent to West Point. So it doesn't so much change the makeup of the wastewater itself, but it just changes a little bit in terms of having a longer peak flows as we send that wastewater back to the system. So I think probably very little impact on the actual nitrogen removal or the amount of nitrogen entering the treatment plant. And maybe Aaron, not sure if you would have anything to add to that.
No, I think that covers it.
Thank you. How much nitrogen is coming from on-site septic systems? And how do on-site septic systems compare to centralized treatment plants in terms of the release of nitrogen and nitrogen removal currently? Steve, you want to start us off?
Sorry, slowed my buttons. Actually, I think if we could get our SMEs both on the OSS side and treatment process side, so maybe Megan can start us out, and then Bryce can follow up.
Sounds good. Thank you, everyone. Yeah, so on the OSS side, there has been some research into specifically the local levels of nitrogen that are coming from OSS. Really the load of nitrogen coming from OSS is fairly small compared to other sources of nitrogen. A lot of this also depends on specifically the type of on-site sewage system. We have a wide range of treatments that can be achieved on a property with an on-site sewage system. So higher levels of treatment will most likely lead to higher levels of nitrogen removal as well. And it also depends on specifically where the OSS is located. So we have some OSS that have been in the ground and being used for up close to 100 years, where they're located in sensitive areas close to the shoreline. And so those OSS are definitely at a higher risk of contributing nitrogen. And those are the ones where we need to have more focus, making sure that they are properly maintained, that we're making sure that they are providing the treatment that they need to provide. And if they aren't, that they're replaced with better treatment options. And then I'll pass it off to Bryce if he has anything else to add.
Sure. For the sake of brevity, I'll just agree with Megan, and we can get on to some other questions. And just a very general statement in that for your typical non-advanced septic system, the level of nitrogen removal would be generally comparable to centralized wastewater treatment plants with conventional secondary treatment, such as South Plant, Brightwater, not designed for biological nitrogen removal. Thanks.
Thank you. Next question. Briefly, what is surface water augmentation? Tiffany, would you like to start us off?
Yeah, I'm going to pull in Jackie to respond to that question.
Sure. Yeah, so surface water augmentation is just recycling water to the level that it can be discharged into a river, into a lake, or potentially, any other generally freshwater body.
Thank you. Next question. King County estimated costs exceeding $6 billion to upgrade its 3 regional treatment plants to comply with the proposed nutrient permit in its comment letter to Ecology dated March 15th, 2021. Tiffany?
Yeah, that is true. And that 6 billion, the question noted, it's exceeds 6 billion. So that that number reflects just the upgrading the 3 regional plants at their current capacity. The Clean Water Plan actions here incorporate in additional capacity for population growth and making sure that we also have nitrogen removal capabilities for that population growth as well. So the 6 billion is a component of the values that you saw particularly in the individual nitrogen removal action.
Thank you. Next question. What is the timeline for making a decision on the appropriate solution for the Clean Water Plan? And is the 40-year plan looking ahead, assuming 2021 as a baseline? Steve?
Yeah, hi everybody again. So on the timeline aspect, one thing I would encourage, and I appreciate everybody's engagement today, and the questions are fabulous, and it shows how astute this audience is. But I'll concede our process is not straightforward. We are doing a different type of process here with our exploratory process. So I would encourage everybody to take the couple minutes to even watch the video that we showed at the beginning of this workshop a second time, perhaps after the workshop, and that'll give you a really nice, accessible rendering of our process here. Then coming out of that, our timeline, we are working to have this discussion now around our actions, and then a discussion in the future around our strategies, which would involve something comparable to this. We're explaining how this all works together. And then moving that forward, we'll have a preferred strategy, which ultimately goes from the King County Executive as a recommended preferred strategy to the King County Council, where it's seen by committees of the council, including the Regional Water Quality Committee, and then makes its way to the full council for a decision and a vote on approval. So that process over at the council, we're hoping to get that process started in 2022, and then it moves through a legislative process and gets set on that timeline. As far as the baseline aspect of the question, yes, 2020 would generally be our baseline looking forward to 2060.
Thank you. We have time for just a couple more before we're going to need to go to our break. Next question is, can you please explain what is driving the differences in the cost estimates? Tiffany?
Yeah, so the differences really reflect the differences for each action. So for example, the action on removing nitrogen to the same levels at each treatment plant, as I talked about, to do so would need adding in a 4th new regional treatment plant. So that in a lot of ways drives that action in particular around the cost reflected in that one. Whereas other actions, say the next one I talked about around the more utility-wide nitrogen reduction, since there isn't the need to construct a 4th regional plant, then those components lead to a different cost estimate. So it really depends on what the components are that are part of the action itself. And I would definitely, as I mentioned at the very beginning of my presentation, there's a lot more information that we're not able to go into today. And there is more information on the specifics about what processes and how they would be implemented at each of the plants in that actions document as well. So definitely encourage you, if you want to get into a little more of the nitty gritty on what's included in each action, to check out that actions document.
Thank you. And now for our last question before we go to break, that question is, can you describe the process that you will use to identify a preferred action and when you expect that to occur? Steve?
Absolutely. So from a process standpoint, again, we're centering on our actions, our strategies, and then our preferred strategy. And really what we're doing with everybody today here, our objective is to try to get everybody grounded in some of the very fundamental aspects of this. So what are, within our decision areas, today we're talking about wastewater treatment. Then when we come back later, we'll be talking about pollution source control. So what are the possible investment choices that are out there? Get everybody grounded in these costs and these water quality aspects. We're also bringing equity into the conversation today. When we come back with our strategies, we're going to have a much different report out. That report out is going to talk more in an outcome sense. And we're going to talk about these outcomes, water quality. What are the outcomes in receiving waters of our different strategies? Cost, or from a cost standpoint, what are the outcomes as far as utility rates and other financial aspects of these strategies? And then we have of course, equity outcomes. I mentioned the benefits and the burdens in a previous response, and we carry that forward. Sustainability is another big part of this. Greenhouse gas emissions has come forward. So, and there's other things, but to note there at the strategies, we bring those outcomes back and we have a conversation around that. We're going to want to collect input on that, that input, as well as all those technical findings. We put that together, and that's what moves to the King County executive around that shaping preferred alternative that eventually goes to the council for deliberation.
Thank you, Steve. And thanks very much to everyone who provided questions during this Q&A session. Next slide. We are now going to take a 20-minute break. You'll see a timer up here on the slide, so we'll know when to come back. Thanks very much, everyone. We'll see you in 20 minutes. Welcome back, everyone. I hope you all enjoyed the break. We have another presentation coming up, but before we jump into that, I wanted to pause for just a moment and hand it to Sonia Linda Benahar for a couple of remarks.
Hi, everybody. I just want to welcome everybody back from the break and remind everybody of the Clean Water Plan core planning questions before we dive into the remainder of the presentation. And the core planning question is, what is the most appropriate path to ensure we direct the right public investments to the right actions at the right time for the best water quality outcomes? And I just wanted to also note that the questions we've been getting have been great. And just a friendly reminder that we'll have 2 more sessions covering decentralized wastewater treatment and pollution source control and product stewardship actions. So we'll also have 2 more sessions for Q&A. So just wanted to invite everybody to continue to ask questions, and we'll get our team members' responses. Passing it back to you, Darcy.
Thanks very much, Sonia. And with that, we will move on to our presentation on decentralized wastewater treatment actions with Ian McKelvey. Go ahead, Ian.
Hi, thanks, Darcy. Yes, this is Ian McKelvey. I'm with Brown and Caldwell, consultant on the planning team, and I'll be talking to you about decentralized treatment. So we're still, reminder, we're still talking about actions here, looking at conceptual programs and projects that could be pursued in the future, looking at them individually. We'll eventually be moving on towards looking at things more holistically in strategies, but for now we're still talking about this decentralized treatment at the action level. Next slide. We're also still working within the wastewater treatment decision area. So Tiffany was going through the actions that we could take at our regional treatment facilities, and I'll be talking to you about transitioning over to what would it look like if we put more investment in decentralized treatment instead. So the next slide has a map of the King County Wastewater Treatment Division service area. Historically, wastewater has been managed in our region with a few large regional wastewater treatment plants. So that centralization provides benefits in terms of there's fewer facilities built and there's some economy of scale associated with that. But decentralization is another option where instead of a few large facilities, we build multiple smaller facilities closer to the source of where the wastewater is generated to provide some benefit in terms of it being more of a local treatment of local wastewater. So we wanted for the Clean Water Plan, being a long-ranging plan and looking at the options for the future, wanted to include that as a consideration for how decentralization might play a role in wastewater treatment in our region. So to look at that, we looked at decentralization across a range of sizes and scales, all the way from small treatment plants located at the same place as other WTD facilities, all the way to small scale of just individual buildings having their own on-site treatment system. So I'll be talking through each stop along the way on that spectrum. Same as Tiffany's presentation, the slides will have one slide on an overview of what the action was, how we described it, how we built it, and then another slide on characterization of that action. This is also all available on the actions report listed there, sections 4.8 through 4.12. So starting at the large end of our scale, the first action shown here is locating decentralized treatment facilities at existing or planned wet weather treatment stations. These are facilities that help us control CSOs in our region, do CSO treatment. So the reason why we were interested in looking at this is the county is going to be making some significant investments in CSO control over the coming years. And at the same time, there's also a need to make investment in capacity increases at the West Point treatment plant, which serves that same area. So there's a question about, is there a synergy in terms of we're going to be making investments in both of these places? Could we just do the investments at one place, and is that a better use of our money, and do we get better outcomes? So to look at this, we, from a representative nature, we looked at how where the wastewater flows in our the West Point service area, where it might make sense to implement this. Settled on the two locations shown on the map there, the existing Elliott West wet weather treatment station, and then there's a planned wet weather treatment station near Harbor Island, referred to as HLKK. So the concept here was that small treatment plants, secondary treatment plants, would be built at the same site as the CSO treatment stations are. They would provide year-round secondary treatment, wouldn't have any impact on the operation or CSO control that the existing or new CSO control facilities have. There's not, we didn't include solids treatment as part of these secondary facilities. It's typical with decentralized, and you'll see this on the other actions. It's typical for decentralized treatment to just do the liquid stream portion of the facility and then return the solids back into their sewer system for treatment at a centralized location. Including solids treatment just makes the facility much more complicated, and it complicates the overall wastewater system to have multiple solids treatment facilities. So in terms of outcomes from our analysis, the water quality impact from this, there would be some benefit associated with these. It's mostly associated with the fact that these decentralized facilities at these locations, we'd likely use a small footprint technology like MBRs or membrane bioreactors, and that those result in higher treatment levels than what's currently being done at West Point. But the scale of how big these facilities are, especially compared to West Point, it's not a major change in water quality in our region. I forgot to mention, Tiffany talked about at West Point, if nitrogen removal is required in the future, that there would need to be a fourth regional treatment plant. I wanted to emphasize that these facilities are much, much smaller than what that facility would have needed to be. Moving on to costs, you can see the cost there. This does require pretty significant investment in these new facilities. It's not cheap building new treatment plants. You see the investments on the order to $1 to $3 billion for the new secondary treatment facilities. And then it also increases operational costs to have more treatment done at multiple facilities. The outcome in terms of affecting West Point's capacity is that we are able to delay an expansion needed at West Point, but because the solids, there's not solids treatment at these liquid stream decentralized facilities, we would still need to do a secondary system expansion at West Point. It would just be 15 years later. Another thing to keep in mind with this action is these facilities, the CSO control facilities have a outfall. There would likely need to be, because we're doing year-round secondary treatment instead of just CSO treatments occasionally, would likely need to be effluent permit modifications negotiated with the Department of Ecology. So that was the large end of the scale. Moving down our scale, slightly smaller is the city scale decentralized treatment. So the concept with this action is that as growth is occurring in our region and we need to increase capacity in our sewers and our treatment plants, would it make more sense to locate small treatment plants where the growth is occurring rather than investing in bigger pipes and more capacity at our regional treatment plants? So to look at this, there's kind of got to be a window where this is effective or makes sense. We don't want, if there's not enough growth in the area, then it doesn't really make sense to invest in a whole new treatment plant. But if there's a significant amount of growth in an area, then the cost of building a new treatment plant is going to be, it's just going to pale in comparison to the cost of building a pipe to convey that flow to a regional treatment plant. So we're looking at kind of a window there where there's enough growth that it justifies building a treatment plant, but not so much growth that it wouldn't be better to just treat that at a regional facility. We looked at several areas where this could be applied. To be representative, we explored a regional facility in the Black Diamond area, and it's the bottom right square on the map there, as representative of what this type of solution might work, where it might work. So similar to the last action, this would include liquid stream treatment on site and then returning solids back into the sewer system where they would get treated at South Plant. Unlike the last action, the facilities were located on the water, so we could discharge the treated water into Puget Sound. This facility all the way out at Black Diamond, it's more likely we're going to create a recycled water that can be used for something like aquifer recharge or some other recycled water benefit instead of a marine outfall. So in terms of outcome or characterization of what we get from that action, Tiffany was mentioning in her regional treatment actions with the advanced treatment, there's a benefit to treating water and not sending it to Puget Sound because this decentralized action wouldn't be sending water to Puget Sound. There is some benefit in terms of removing that load from Puget Sound, but it is a fairly small facility in the grand scheme of how large WTD is, representing less than 5% of total flows in King County system. So there would be some benefit, but it would be fairly small. The investments in terms of costs, you can see, as I said, there's a window where this could be effective. And so as you can see, the cost for building the new facility and operating it is about on the same order as the avoided costs associated with not needing to do capacity expansions in the conveyance system or at the treatment facilities. So it is, this facility that we looked at as representative could be cost competitive. But I think something to keep in mind is that that Black Diamond representative solution, that was, one of the best opportunities in the region. So I think a takeaway here is that the number of opportunities where this could really be cost effective are limited. Other outcomes, like I said, this facility, because it's not located near the water, there's an opportunity for creating a recycled water resource, and that would have opportunities and require partnerships. And then obviously locating a new treatment facility in a community would have impact on the community around the facility. So the third scale here, continuing to move smaller, looks at areas in the WTD service area that aren't currently connected to the sewer system. Either they're on septic systems or they're undeveloped land, but we expect over the next 40 years that those areas do get developed, or that the areas on septic are connected to the wastewater system sometime in the future. And so the question is as those areas are developed, or as these areas on septic system are ready to convert over to the wastewater utility, would it make more sense to build community scale decentralized treatment rather than building the sewers and pumps to convey those flows to a regional treatment facility? So to explore this, we looked at areas across the WTD service area where this might make sense. The two locations shown are, again, representative of what this type of solution might look like. If this gets pursued in the future, there might be additional areas where this makes sense, or there might be different areas where it makes more sense. But this was meant to be kind of representative of what this could look like. What we're really looking for is an area that has enough density that the amount of enough density and growth that the amount of flows that would be treated at this community center aren't so far flung or aren't so small that it doesn't make sense to build a community center scale decentralized facility. We also are looking ideally for areas that are fairly remote to the existing sewer system, because those more remote areas are going to require more cost in terms of the conveyance infrastructure needed to get those flows into the centralized utility. So again, these two areas were selected to be representative of what a community scale decentralized facility could be implemented. So similar to the other decentralized treatment actions, these would be liquid stream treatment facilities. Unlike the other ones, because there's not sewer service in these areas right now, we can't just put the solids back in the sewer for them to be treated at a regional facility. So instead, the solids would be moved into a truck and then likely trucked to South Plant for treatment there. Sorry, one last thing on the last slide. Similar to the other actions where these are located, these facilities would create the opportunity for recycled water use. It could be something similar to what King County is doing at the Carnation treatment now, where water is being beneficially used for environmental augmentation. Okay, next slide. On the characterization, same as the last action, these facilities would be creating recycled water that doesn't end up in Puget Sound. There is a water quality benefit there. These facilities are even smaller though, so the benefit to the water quality is even less. The investment, again, it's a pretty hefty investment for these new community scale facilities on the order of $1 billion. They also require additional costs for operations and maintenance. Unlike the last action, these community scale facilities, just how small they are, it really doesn't make a significant impact on the need for capacity increases that are currently being planned. So the amount of avoided cost is really negligible based on our analysis. And then, like I said, there's an opportunity for additional recycled water from this additional resource recovery. And then there's also would be impacts to the communities where these facilities are located. So then the last, on the other end of the spectrum from where I started, all the way to building scale, decentralized treatment facilities is what we looked at next. So in this action, what we're considering is as growth occurs in our region, we've really taken a focus on densification in our region. So as we get more density and as technology improves, is there an opportunity to have on-site facilities built as part of new developments or significant redevelopments and have the wastewater treated on-site rather than connecting into the wastewater utility? So we looked for this one across, again, across the service area, focusing on areas the Puget Sound Regional Council has designated as a regional growth or manufacturing industrial center, and asking to conceptualize it, what we're thinking is King County would work with local authorities to revise building codes so that they require future developments or major redevelopments to over a certain size threshold to include on-site treatment as part of that development. To conceptualize this and characterize it, we used 100,000 square feet as kind of our scale of where this would be triggered or needed. But that obviously, if this gets pursued further, that number would need to be refined and studied further. So the on-site treatment, we'd leave those how specifically that gets implemented, largely open to the developers, but we would put some bounds on what would be allowed and what wouldn't be allowed. Likely it would include on-site treatment, including recycled reuse of the water that gets treated. There was a question in the last section about waterless technologies that could be an example of an on-site way of managing wastewater so to reduce water footprint. Some of these new technologies could manage the solids at the building scale. Some of them might return them back to the sewers. So either way, though, there would still be required to have a sewer connection, if only just for emergencies in case the on-site system fails and isn't available. So in terms of characterization, same as the last three, we see a reduction in how much water is going out and treated wastewater is going out into Puget Sound by virtue of these facilities treating the water on site and reusing it on site. This one, the way this would implement out is that it would take some time for King County to negotiate those building code changes, and then for redevelopment or new developments to occur over the 40-year period. So the impacts or outcomes from this action are more backloaded towards the later periods of our planning period, just as more developments occur and more on-site systems get built. So that's when we would likely see more of those, start to see the benefit of that to the water quality. From a cost perspective, King County's role would largely be as an administrator, working with the building authorities to negotiate those code changes, working as inspectors to make sure these facilities are being implemented correctly. The bulk of the cost would fall on private property owners who, are doing this development or redevelopment. So you can see there's a pretty hefty investment that would be required there if this type of approach is taken through the region on the order of $4 to $11 billion. I mentioned the benefits of this are largely, we'd see them mostly towards the end of the planning period, so closer towards 2060. Because of that, the regional treatment system capacity increases that Tiffany was outlining would likely still be needed. But over the long run, there might be, even beyond 2060, might be the benefits of this in terms of capacity reductions might start to be seen. This would require a pretty significant change in how King County interfaces with other partner agencies. There'd also be benefits to resiliency by having literally hundreds of small scale treatment facilities through the region, but there might also be reliability issues driven by less experienced O&M staff or operations and maintenance staff operating these facilities than the King County staff at the regional treatment plants. So those are the 4 actions that we looked at. The next 2 slides are going to cover some key takeaways that we wanted to highlight. So the first one there is, as you might guess, shifting over to a decentralized approach would be a pretty major shift in how the region manages wastewater. So it would require quite a bit of collaboration and realigning our regulatory, administrative, and operational practices that have been developing over the last 60 years. The implementation of decentralized treatment would have some influence on capacity in our regional system, but as I was saying, it's not not so much that we would abandon our approach to at the regional treatment facilities. This is more of a partnership with the regional solutions than a shifting wholesale to a different approach. I also mentioned in most of those actions, there's an opportunity for treated water to be diverted away from Puget Sound and used for recycled water. As we talked about in the last segment, the details of how exactly that water gets used, where it gets used, would still require further study. More takeaways associated with the having a lot of these facilities means that there needs to be more staff in the region trained to operate and maintain these systems. Like I said, with the building scale as an example, there'd be literally hundreds of small treatment systems throughout the region. So it would take more staff and more expertise than the current centralized regional wastewater utility requires. It also increases the operational complexity of our wastewater management as a region. Having lots of small facilities instead of a few few large facilities creates more complexity. For example, I mentioned most of these facilities would return the solids back into the sewer system. So now we'd have both liquid stream treatment plants in some places and centralized facilities doing a lot of treatment and doing solids management. Those solids would come through the sewers or they could be trucked there. So all this just increases the complexity of our managing sewage in our region. And then the last one, I mentioned this in the building scale decentralized treatment action. More facilities could create more resiliency in terms of if any one facility is no longer operational, and we have other facilities that are still operating and providing wastewater treatment in our region. But it can also create more opportunities for something to go wrong in terms of, the more equipment you have, the more likely it is that something somewhere will break. So same with the other actions. We looked at these actions also from a lens of how can we improve equity in our region. And there are several opportunities with this decentralized treatment actions. So the first there is how these facilities are sited, designed, operated, or all have an opportunity to promote equity in the region. So for example, we could prioritize siting these locations in industrial locations where they wouldn't displace homeowners. King County's design standards include odor control and architectural features that are meant to benefit the surrounding community and be not and to blend in and be a good neighbor to the surrounding community. And then community amenities could be things like green spaces as part of the facilities, or community centers, educational centers. So all of these can result in new facilities being a place where that the community benefits instead of being a burden on the community. Another equity opportunity is equitable access to financial resources. Some of these actions could place financial burden on some communities more than others. So, for example, places that are people who are served by septic systems right now to connect to the sewer utility have to pay into a capacity charge. And that capacity charge can be a financial burden for some people and discourage being connected to the sewer system and benefiting from our utility. So equitably delivering this program could include financial resources or assistance to help relieve that burden for communities. There's also an opportunity to equitably distribute recovered resources, this recycled water, for priority communities that could benefit from it, businesses or community organizations. That could be done more equitably by prioritizing those priority communities to receive that water, or providing, again, the financial resources in terms of reduced rates or something like that. And then the last one listed there is, as with all of these programs, King County, how the program is delivered is important for the equitable outcomes. So King County would do significant amount of community outreach and engagement to hear priorities and receive feedback on the needs of the community. And the county is really striving to be responsive to the interests and priorities of historically disadvantaged communities. So that's no exception here. So my last slide here is, again, connecting to how does this area connect to the other decision areas. So like I was showing in the slides, decentralized treatment is a component of our wastewater, how we treat wastewater in our region. So it's obviously connected to our wastewater treatment decision area. It's also connected to our conveyance decision area, the capacity in our sewers, pipes and pumps. Decentralized treatment and capacity are go hand in hand. As with the regional treatment actions, investing in new infrastructure, building new treatment facilities, new pipes, it's all adds to the portfolio of assets for King County's asset management program to manage. So that would need to be incorporated in terms of financial planning of how we're going to maintain and plan for refurbishment and replacement of these assets in the future. And then I've said this a few times, the recycled water that could come from these decentralized facilities obviously connects to King County's efforts to recycle resources from wastewater. So with that, thank you for your time.
Great, thanks, Ian. Thanks, everyone. We've got a lot of questions in the Q&A box, so that's wonderful. We are going to go through those now. First one, can you explain the concept of treating the wastewater and then returning the solids into the sewer line for final treatment downstream? What process is done at what site? Tiffany?
Yeah, so basically with those decentralized treatment plants, they treat the liquid stream, and then as they're treating the liquid stream, solids are settling out or being removed. And so then those solids are then, instead of going into a separate solids treatment process at the decentralized site, they go back into the sewer system and then are sent to one of the regional wastewater treatment plants, along with all of the regular influent wastewater, and then get treated there through the regional treatment plant processes. So that's the general concept. Also, I thought I'd pull in Jeff Hansen, I believe he had a couple of examples he could provide on that.
Yeah, sure, Tiffany. You explained the concept. Just a good example locally here in Western Washington would be the LOT Clean Water Alliance down in the Olympia area. LOT operates a decentralized satellite membrane bioreactor facility that separates liquid stream from solid stream, generating 1 to 1.5 million gallons per day of recycled water. The solids from that go back into the sewer, like Tiffany explained, down to LOT's central facility in downtown Olympia, the Bud Inlet plant, where about 10 MGD or so of dry weather flow is treated. And that's where all of the solids processing occurs for LOT down at that central location. So just an example of that concept here locally.
Thank you. Next question. The Gates Foundation has funded the development of a self-contained treatment facility that essentially converts sewage to clean water and energy. have you considered a range of this style plant? Tiffany?
Yeah, great question. So Gates Foundation, I believe what this question is referring to is the Reinvent the Toilet challenge that they've had. And my understanding with that is it is really focused on areas around the world that don't have any kind of centralized treatment, and really focused on a lot on the individual scale. So, we are in a little bit of a different situation with kind of having the situation that we have here. With that said, our building scale treatment action that Ian just talked through is representative of how something like that could be applied here. So the types of technologies that the Gates Foundation work has been developing, that's a type of technology that perhaps could be applied to a building scale type treatment, decentralized type treatment, because there are various types of technology that could be used for a building scale treatment. So you might see something like that be applied here in that manner.
Thank you. Please explain what you mean by solids when talking about putting solids in a truck and taking to South Plant. Are they truly solid to a layman, or are they rather liquid? Ian?
Yeah, some of the specifics might depend on when we got to the point that we were actually doing facility design. Likely though, if we're talking about trucking solids, there would likely be processes used to try to remove water just so that there wasn't a substantial number of trucks that would need to be going back and forth between these facilities. But I think it's most likely that the layperson would still see this as pretty liquid stuff, not super dry solid. It still have a fair amount of water in it.
Thank you. Would there be some sort of homeowner or developer incentives to use building scale decentralized treatment systems if that were enacted? Steve?
Yeah, thanks, Darcy. On this question, I think it's good, another good opportunity to look at the Clean Water Plan here. And so the region has been since for about the past 50, 60 years, pursued a regional wastewater treatment approach where we have 3 regional treatment plants. The sewage comes there and is treated because we're on the threshold of big decisions here about potential investments in the regional system. Those investments that Tiffany Knapp went over, we're looking closely at decentralization before making any of those big decisions to see how that might fit in. But really none of the administrative and programmatic infrastructure is in place currently for the region to shift rapidly into a decentralized approach. So what we're asking here in the Clean Water Plan is, what does decentralization look like? Is it part of our future? And if it is, we need to work as a region and bring that administrative and programmatic aspect into that in order to make that shift. So the short answer that I'll conclude with is that we really don't know about those incentives and exactly how those fee structures would look, but we are trying to explore it as far as cost, water quality, our system health and operations to see if it merits further work and could be part of a preferred strategy going forward.
Thank you. Couple questions now. Can you visualize for us a few different building scale facilities? What does it look like? How does it integrate in building design? Are composting toilets like those used at the LBC Bullitt Center part of a future design option? I think we'll pull in our subject matter expert, Jackie Klug. Jackie?
Hi, yes. So there are a lot of different examples from around the country and also locally. And, it's really centered around the different streams of water. So most of the decentralized buildings kind of capture rainwater or stormwater, and we'll be able to reuse that, as well as the gray water that, the water from sinks. And then the black water would have its kind of own treatment process. And so they can be integrated well within the building scale. There's also examples locally. I toured one in Portland that was a series of buildings, within one development. And so they had a number of different technologies, a wetland treatment that was treating the stormwater system, an MBR, a very small one in the basement of a parking garage that was treating the black and gray water. And there would be other, composting toilets or some, waterless urinals could be part of the package as well.
Thank you. Next question. When you say decrease in amount of discharge to Puget Sound, you mean relative to another curve, not an actual decrease? And along those lines, why not discuss infill and retrofit approaches to creating decentralized facilities within our existing dense areas, not just the fringes? Tiffany?
Yeah, I'll start out with the first question and then pass it over to my colleague, Steve Tolzman. So when we say decrease in the amount of discharge to Puget Sound, we are talking about an actual slight decrease in flow. So the decentralized options here are looking at taking wastewater that would be flowing into the centralized system and would be flowing to the regional treatment plants. And as Ian talked about, for most of those, we would then be not sending that. If we built the decentralized plants, then that effluent would not go to Puget Sound. It would most likely be recycled. So there is a slight decrease in the amount of flow that either currently or is projected to go through the regional treatment plants and then ultimately the treated water to Puget Sound. And then I'll turn the second question over to Steve.
Great, thanks, Tiffany. Yeah, on the infill development and the retrofit, I mean, the building scale action that Ian McKelvey went over, the building scale decentralization, that looks very much at infill redevelopment in the context of the Puget Sound Regional Council designated urban growth centers. So that's very much looking at that aspect. When you get out of those urban growth centers, and particularly when you get into areas that are already sewered, if it's single family residential development, there's already, and it's already sewered, there's already a sewered solution in place or a wastewater solution in place. It would really just be a trade, and you wouldn't get, what you would get out of it would likely be minimal at best. And then, however, so we do, from a densification standpoint in areas that aren't sewered, also Ian McKelvey went over the kind of what I would call micro facility. We called them the neighborhood, community/neighborhood systems there. So those could all be deployed in, those are representative locations where those could all be deployed in an infill context.
Thank you. Wouldn't it be more efficient and effective for the county to build and operate these business scale treatment systems? Otherwise, there will be major equity issues and cost issues between competing businesses. Steve, would you like to respond?
Yes, and I think I'll just loop us back to a comment I made about this being a paradigm shift for the region from regional to decentralization. And I think, the question that we have here is something that if we see the merits through this planning exercise of decentralization means it's part of our region's future, that is an aspect that would need to be looked at closely in the programmatic administrative side. We do assume, and I believe Ian McKelvey included this in his remarks, that we assume that the King County could remain in a role as a regional wastewater provider in providing some ability to support those systems if we went to building scales decentralization, for example. We didn't get into assumptions as deep as the operations of those systems. So yes, there's an equity issue and a cost issue in play there. And yes, that's something that needs to be, if we're going to pursue this, details need to be hammered out on.
Next question is regarding ESJ, jobs. Is job minority training a priority? Nicole, would you like to respond?
Yes, I would. So yes, job training is an opportunity that is being explored and considered for these actions. And so there are a number of existing county programs that represent some of those opportunities to help marginalized or priority communities acquire better jobs. And those include the apprenticeship programs, which build partnerships with businesses and labor and the community to create skilled workforce, as well as priority hire program that the county has that provides opportunities for people interested in construction careers to gain additional skills. And the county does have a number of other programs related to contracting and procurement that would provide job opportunities.
Thank you. We have time for a couple more. For city scale decentralized treatment, Black Diamond was evaluated as other locations explored did not meet planning criteria. What evaluation criteria was considered? Ian, would you take this one?
Yeah, sure. So like I said, there was, for that approach to work, you kind of need that window of enough flow for it to be worthwhile to invest in a new treatment facility, but not so much flow that it becomes so expensive that a smaller or building a larger pipe would be more cost effective. So when we looked at those different areas, we were looking for increases in population growth on the order of about 15% over the or more over the planning horizon, but didn't want flows at these treatment facilities to be larger than around 10 mgd. So trying to find that window of increasing flows, but not so much additional flow that you're essentially creating a new regional treatment plant. So like I said, there's, we've Black Diamond looked like a promising area. There might be other areas, but that kind of creates a window of where that approach is suitable.
Thank you. Seems like there could be some significant equity gains if you take a more decentralized approach. Can you evaluate the cost and benefits of combined approaches? Some centralized with some various decentralized solutions, a combination of regional, city, community, building based? Steve?
Yes, and where we're going, that's where we go next. These are our actions, or what we call our building blocks for our strategies, as we demoed in our video here in the beginning of this session today. And so we will look at how these, elements of all these can be put together into a strategy that converts into a regional wastewater solution, or how the region manages its wastewater. So we'll take a look at that, and then we'd report out on those outcomes, including costs and water quality benefits.
Thank you. Next question. I think we have time for about one more question. Are the costs presented intended to include the costs associated with new collection systems, or are they limited to comparing treatment facilities to treatment facility costs?
Yeah, so the decentralized costs that were presented, those were meant to be kind of all inclusive for that solution. So it includes the if there's collection system modifications that need to be made, or if there's new facilities that need to be built. It would include those costs, not only to build them, but also to operate them. And also avoided costs if it means that we don't need to expand a part of the system that otherwise would have needed to be expanded, then that was included as an avoided cost. But those costs don't show the overall cost of wastewater treatment in our region. Tiffany was showing costs for operating our regional treatment facilities. Those costs would still be needed. We'd still be needing to operate, maintain, and expand our regional treatment facilities as well.
Thanks very much. That is all the questions we have time for in this session. As a reminder, we do have one more Q&A session after our next presentations. Next slide. You can see this is where we're at in our agenda. We are now going to hear presentations on Introduction to Pollution Source Control Concepts, followed by Pollution Source Control and Product Stewardship Actions. And I will welcome Elizabeth Lowell for these presentations. Go ahead, Elizabeth.
Yeah, great. Thank you, Darcy. You've heard me a little bit before, but my name is Elizabeth Lowell. I'm a technical consultant supporting the Clean Water Plan, and I am with HDR. And yeah, I'm going to talk a little bit, shifting gears away from treatment to pollution prevention, or what we're calling pollution source control and product stewardship. So next slide, please. So in terms of decision areas, we'll be exploring how we can prevent pollution at the source and how that fits into the Clean Water Plan through the actions that we're exploring. Next slide. So, there's a lot of sources of pollution, and while some of those go through treatment, some don't. And these include sources from yard runoff, road runoff, agricultural sources, and even direct sources into our water bodies from, legacy pollution. And then I'll also note that even though some sources of pollution are treated, like wastewater, for example, not all pollutants are removed through the regional wastewater treatment system or stormwater treatment. So the actions in this section are really going to explore how pollution source control can address some of these sources of pollution. So there's a lot of sources of pollution. They come from all sorts of products and processes that really span a wide array of uses. Products could be used by consumers in their daily lives, businesses, manufacturing and industry. So there's some examples there listed on the slide, everything from cleaning products to prescription medicines, to things like trash and microplastics. And I do just want to note on terminology, when we say sources, what we mean are that's what's generating the pollutant, while the pathway is how it gets into a water body. So for example, PAHs are a product of combustion from, say, wood burning stoves, and they can reach waters through deposition from the air. But they're also used in creosote coatings, which are a direct source, like say creosote pilings in Elliott Bay. So we'll use those terms a lot, and those are important to keep in mind. So, in a nutshell, source control involves the reduction or elimination of pollutants before they enter the wastewater stream, stormwater, or through other pathways that eventually get to water bodies. And it includes a variety of what we call control measures. And control measures can range from, say, voluntary behavior changes that are affected through education and outreach, to more mandatory or compulsory measures like, a product ban or a threshold that limits use. So we have the examples of the control measures listed there on the slide. And I'll note that often, successful source control really relies on a combination of control measures. So that could be education and outreach around a safer product, followed by a product ban or safe disposal options for that product. Lots of regulation that impacts source control. This is anything from national pre-treatment standards that set limits for specific industries, federal, state, local regulations and ordinances that might ban products. And then Washington State also has a new law called Safer Products for Washington, and that's really designed to reduce the use of toxic chemicals that are just beginning to emerge. And really, source control is very multi-jurisdictional. It's administered at really all levels of government. So why is the Clean Water Plan exploring this topic? In a nutshell, we're trying to understand if there are more efficient or effective methods to address pollutants of concern than wastewater treatment that result in better water quality, or maybe help to reduce some treatment needs, or possibly enhance the value of recovered resources. So what we see today is we know that pollutants that have regulatory limits are still ending up in our waterways. And then we also know that some pollutants are really just beginning to emerge, and we don't have a great deal of information on them. And then finally, some sources of pollutants that we understand really well are extremely complex. So the actions that we've developed are really trying to explore each of these considerations. So that's kind of the background on the key concepts of this decision area, the pollution source control and product stewardship. So in the next section, I'll introduce the actions that the plan's exploring. All right, so into the actions. The third and final time, we'll just remind folks of where we are in the plan process. We're really in that action exploration phase. Some of these actions are going to require significant changes. Others are more consistent with past practices, and we're kind of continuing to evolve and fine tune these actions and take them into strategies. Slide, thanks. And so again, just where we're at with everything that the Clean Water Plan is exploring is we're really focused in on preventing pollution at the source. So I'm going to talk about 3 actions that we're exploring. The first is existing source control programs. So tracing and controlling pollution sources to prevent pollutants from entering waterways is already an underlying part of a lot of King County's existing operations. So we're exploring kind of what that looks like and how that affects other areas of the plan. The second action is looking at increased source control of existing pollutants and sources. So this is really exploring what more can be done with some of the pollutants that we're already working to control. And then third and finally, we're exploring source control for emerging pollutants and sources. So this is really exploring pollution control for emerging pollutants that are found in, products or substances that really don't have federal or state regulatory limits or guidance around them. So just like in the other sections that Tiffany and Ian went through, we'll describe the scope of the actions, we'll provide a description and a characterization of each, and then just that final reminder that there is more detail available in the Characterizing Water Quality Investment Options document. All right, so our first action, as I mentioned, it's really meant to maintain existing King County pollution source control programs for municipal wastewater, stormwater, local hazardous waste, industrial waste, and then also the pollution identification program that early on today, Megan talked a little bit about in the Q&A. And these King County programs are really focused on pollutants with federal, state, and local regulatory limits or ordinances. So these are things like bacteria, lead, mercury, organics, and even things that get flushed down toilets that really shouldn't be, like fats, oils, and grease, sometimes called fog, trash and floatables and that kind of thing. So some examples of existing control programs are things like education and outreach, tools and resources around, natural cleaning alternatives or landscaping practices. They include safe disposal sites for things like hazardous waste or unused or expired prescription drugs. The county operates an industrial waste program. This regulates the discharge of pollutants into local and regional sewer systems. And then finally, something that may not necessarily come to mind, there are programs that control air pollution, and air pollution can have an indirect impact on water quality. Existing pollution source control programs are implemented by a lot of different county departments. There's a lot of collaboration with external agencies, with nonprofits, with community-based organizations, and there's an existing framework to support that needed collaboration and partnerships. So you'll hear me say that a couple of times because really that's going to apply to all of our pollution source control actions. Some considerations for the existing programs is while they really are targeting a lot of pollutants, some of the emerging pollutants without regulatory limits are not really included. And then, as I mentioned before, some of those that do have regulatory thresholds and pollution source control programs, we're still seeing them those pollutants impairing water body health. And then lastly, and again, this is really true for all pollution source control actions, many of the control measures rely on behavior change, so not a particular treatment technology or process. And when things are voluntary, they can sometimes take longer to have an impact. So characterization, pollution source control really reduces loading from a wide variety of pollutants. And for this topic in particular, we're really including, but even going beyond the water quality parameters that we're assessing for the Clean Water Plan. And the efficacy of the current pollution source control programs is really actually just observed through today's water quality and the pollutant loadings that we're seeing today. As far as cost goes, I just want to point out that this includes cost for all programs, really ranging from education and outreach to hazardous waste management and collection, incentives for voluntary source control. And those are ranging from, an estimate of about $1 billion to $2.4 billion. There's also some revenues associated with existing programs, and those are for things like hazardous waste management collection. And then lastly, I just do want to point out that there's a lot of state and federal grant funding, and the county actually receives some of that grant funding. But for our purposes, that's just included in the administrative costs that we have here. Next slide, please. All right, so moving on to our second action. As I mentioned before, this action would implement an expanded pollution source control program, and that's really focused on increasing the amount of control for pollutants that are already a part of existing King County pollution source control programs, the wastewater treatment program, and all the existing programs, but they're still found in water bodies at levels of concern. So really what this program would do is to augment, either augment existing source control mechanisms through, additional funding or expanding the reach, or add new control mechanisms for pollutants that, they currently have some control mechanisms in place. So the sources that we targeted, they typically represent a large share of the pollutant loading that we know, and they're good candidates for control measures. So, for example, loading studies show that copper from brake pads and herbicides and pesticides are a significant source of copper and stormwater runoff. So we know that street sweeping is effective in controlling copper. So we might look at augmenting that. And then also look at potentially expanding control mechanisms for herbicides, pesticides by, doing more education and outreach, and then maybe even looking at product substitution or potentially product bans. Slide. So there's some really similar considerations with this action as with the existing program. So I'll just note a few additional things here. We're talking a little bit more about some of these compulsory controls or mandatory controls. And those can also take a significant amount of time and collaboration to implement. And I'll also note that, the existing programs that are in place, they really have been very effective. So in a lot of ways, this action is really seeking to target those harder to get at sources. So it's kind of trying to do a little bit more beyond what we're already doing now. So just want to give folks a sense of the pollutants and the control measures that we're talking about for this action. So looking at, as I mentioned, copper from a variety of different applications, zinc, targeting galvanized materials specifically, trash and floatables and litter, nutrients, so that's nitrogen and phosphorus, and then total suspended solids. And you'll kind of see from the column there on the right that with the exception of total suspended solids, it's really not just one control measure that's really going to be a part of the program. It's looking at a suite of things and implementing those over time. So what does the characterization look like for increased source control? So from a water quality standpoint, we're really looking at the effectiveness of the different control measure for a given pollutant and a given source of that pollutant. So for really targeted sources where the pollutant makes up a lot of that source, the efficacy, the effectiveness can be pretty high, 50 to 70% removal for just that targeted source. But we also see, lower effectiveness when control measures are more voluntary. And that's not always the case. Sometimes really targeted behavior change campaigns can be highly effective, but generally speaking, we estimate lower effectiveness. And of course, because we're talking about all different pathways, we're going to be impacting all water bodies. When it comes to cost, the kind of order of magnitude estimate is about 80 to 200 million in administrative costs. And there are some costs to the region, and that's getting into that augmentation of street sweeping. And so, the administrative costs, these include things like labor and materials for education and outreach campaigns, expanded incentives, and then a lot of the additional regional coordination that's needed. All right, so moving on to the third and final action. This is source control for emerging pollutants and sources. So this is targeting pollutants without current federal and state limits. And it's also targeting pollutant sources that are emerging and difficult to control. And in a lot of cases, the pollutants are found in a really wide variety of products, and they're increasingly found to be harmful to ecological and human health. And conceptually, kind of a key component, a lot of the anticipated control measures would be enacted pending the results of additional monitoring and modeling. So these pollutants are emerging, we don't know a lot about them. So we have to do additional monitoring and modeling to understand that better, so we can then really target the control measures and tailor them accordingly to what we find out from that modeling. Slide. So I've noted a couple of times there's some really similar key considerations that are a part of all of these actions. But in the case of emerging pollution source control in particular, as I've noted, the monitoring and modeling is especially necessary so that we can understand, where are the heaviest concentrations of pollutants coming from, what products we might be looking at, and which pathways could be targeted. And so for this action specifically, we'd anticipate there'd be a lot of coordination with the state Safer Products for Washington law, which is also looking at really similar pollutants. So again, to give everyone a sense of the pollutants and the control measures that are included, they're a pretty wide variety, and in some cases they're more of like a class than a particular pollutant. So we're looking at bacteria from populations experiencing homelessness, and they don't have access to adequate hygiene services. So this is an example of a source that's very complex versus just the pollutant itself. We're also looking at microplastics and nanosilvers, PFAS, and a wide variety of products that include those compounds, and then personal care products, which is also kind of a wide variety. And for those, you can see there that the control measure really leads with monitoring of sources so that we can then develop additional control activities. And then, of course, we have phthalates and anti-ozonants. I know there were some questions on that earlier that have a little bit more specified control measures now. So things like, finding safer alternatives and then looking potentially at product bans and things like that. So our final characterization. So this action's a little bit different because it's focusing primarily on emerging pollutants and sources. Loading in most cases has yet to be quantified. So that's a parameter that we're really looking at more qualitatively. And in this case, we're only able to estimate the effectiveness of the anticipated control measure. So we don't know exactly how much it will remove. We just have an estimate of the percent removal. And so similar to the previous action, it's really kind of a broad range of what that effectiveness might look like. So anywhere from, as low as 5% for more kind of behavior change type programs upwards to, 70% for really more targeted compulsory measures. And again, we're going to see impacts across all water bodies and all pathways. So the costs are estimated to be an additional about 165 to 400 million in administrative costs over the lifetime of the plan. And again, that's the same kind of labor and materials for education and outreach. That includes the monitoring studies and planning, and then a lot of the coordination activity that would happen at the local and regional and state and even multi-state level. There's also some cost to the region noted here, about 22 to 55 million, and that's really targeted at specifically at structural BMPs as a kind of a near-term solution for some of the anti-ozonants that are coming from tires and entering our storm water, although there's other control measures that would be layered on with that. And as I've said, for all the actions, there's that reliance on regional partnerships and collaboration and just, legislative action for some of these compulsory controls. So we'll finish up with some key takeaways. I've said this now, I think on every slide, but, many jurisdictions have a hand in these programs. And in some cases, there's already an existing kind of collaborative framework. So the local hazardous waste management program, for example. But then in other cases, there might need to be kind of new avenues for collaboration. Another takeaway here, and really applies to that third action, is when we're talking about emerging pollutants and sources, we really are going to rely on monitoring that can be complex, just to be able to develop our targeted control mechanisms in the future. And then another takeaway here, and this is, unique to this decision area, is that source control is really reliant on behavior change of people, of businesses, of industry, and that may be voluntary, it may be mandated, but it really puts the responsibility on others to sort of help with controlling pollutants in our waterways. So when we talk about some of these compulsory or required control measures, usually those come with a need for regulatory action. That might be an ordinance. It could even be, say, a federal threshold limiting a certain pollutant. And so there's usually a lot of monitoring that supports that. And there has to be a lot of collaboration with stakeholders so that whatever gets instituted is manageable. In a lot of cases, say, a safer product alternative is identified first before, say, a ban takes effect. So really likely that these sorts of control measures, could be kind of long-term. One thing that we didn't really talk about is there's a number of pollutants that could kind of fit the bill for either expanding existing pollution source control or some of these emerging pollutants, but they're just not suitable for source control for a number of reasons, either because they can't be controlled using available mechanisms, or they have control needs that are just really far outside King County's sphere of influence. So these include things like, excreted pharmaceuticals. The existing control programs collect expired prescription drugs, that kind of thing. But when we talk about excreted pharmaceuticals, that's just not really suitable for control, or even things like illicit drugs, where that's just really far outside of King County's sphere of influence. And then lastly, just to point out that, beyond water quality, there really are some additional benefits of pollution source control. So, a safer product alternative could result in less waste generation or an increased resource conservation. So there really are some benefits that go kind of beyond clean water. All right, and getting into opportunities for equity and pollution source control. So, the first is really thinking about equitable access to financial resources. So, a product ban or a product substitution or potentially waste disposal requirements for business, those could increase costs for households and businesses. So we want to make sure that there are, tools and financial assistance available to help offset that, be it in the form of incentives or other things. We also want to support environmental justice by addressing the different uses of water bodies by different communities. So some communities might have a certain cultural value they associate with the water body or something like that. So when we design the monitoring and the studies and things like that, we want to make sure that we're really not overlooking any potential impacts of certain pollutants. And then finally, kind of those last two items on the slide there, all of this really rests on inclusion of communities. And so that could be engagement with community-based organizations to really leverage their expertise so that, we're developing materials that are culturally appropriate and accessible and really engaging with all communities. All right, so as we've noted in the other topics we've talked about today, a major element of the plan process is just recognizing how integrated these actions can be. So I'll just point out a couple of examples for pollution source control. So when we think about wastewater treatment and stormwater treatment, being able to remove pollutants before they even get into those streams can really have an impact on what treatment is needed and the treatment plant processes. Kind of similar when it comes to resource recovery, removing some of those pollutants at the source can contribute just to the quality of those recovered resources. And then finally, pollution source control, it might remove some pollution that once it's emitted, once it's out in the environment, it can be really hard to remove. And so it can kind of benefit that by eliminating that need. So I think with that, I will turn it over to Darcy for Q&A.
Thanks so much, Elizabeth. We will now start our fourth and final Q&A session. On this, we are going to focus first on questions related to the presentations we just heard on pollution source control and product stewardship. And if we end up having time, we may loop back to remaining questions related to previous topics. Okay, our first question, how might we invest in R&D for green chemistry entrepreneurism? What can we learn from major corporations collaborating with the circular economy? How can we support green chemistry curriculum design in local high schools and community colleges? And we will start with Nicole.
Yeah, great. These are great questions, great things for the team to continue to think about. To start off, some initial thoughts are that the county does have some existing youth engagement programs, and so there may be opportunities that we could explore more in linking those opportunities to this action. And then for the source control on emerging pollutants action in particular, we're acknowledging that there will need to be new and expanded monitoring of targeted pollutants and sources to better understand those. And perhaps there's a connection there as well with the R&D that you are suggesting. I also want to turn this over to one of our subject matter experts, John Carlton, to see if he has additional thoughts.
Thank you, Nicole. I'm John Carlton. I'm an engineer and a consultant to the project from HDR. I guess the explosion of all the different types of products that we work with that become emerging pollutants of concern, such as microplastics, PFAS, and other types of products found in healthcare, et cetera, are going to continue to need to emerge in order to address, the fact that they become a pollutant down the line. We do recommend that the county, continue to partner with universities and others that are looking, like industry groups that are looking into new products or new substitutions of materials. But we can also look at approaches such as extended producer responsibility, or EPR, which basically puts the onus of downstream impacts of products on the manufacturers. So a lot of circular economy type of approaches that many cities, states, counties, and some businesses are working with do look back to the manufacturers of products to try to come up with other products or better products, or ways to collect materials such that they do not end up in the waste stream down the line. So that is an approach that would help to probably facilitate not only product manufacturing, but also a lot of research that could go through green chemistry through universities or even some high schools.
Thank you. Okay, next question. What are the actions for pharmaceuticals under emerging pollutants and sources? Are they included under the category personal care products? Elizabeth?
Yeah, thanks. And I saw that kind of helped answer this question as we got to it, but we'll just kind of reiterate that in King County's existing pollution source control programs, There are safe disposal options for, expired or unused, unneeded prescription drugs. But generally, when it comes to just the excretion of those drugs, we're not including those in the pollution source control actions.
Thank you. Next, currently, what is the largest source of contamination of dirty water? Are all pollutant sources broken down by percentage, or does it vary too much? And I think we'll start with Elizabeth.
Yeah, so really good question. There is a huge degree of variation depending on the pollutant that we're talking about. So just in the context of the pollution source control actions, we really looked at a number of different sources to understand where some of those things were coming from. And sometimes it's stormwater, sometimes it's through wastewater, and a lot of this came from some Department of Ecology studies that have been done, as well as the county's own, water quality monitoring. And so it's pretty variable, and sometimes it might be, one pollutant makes up the majority of it, and then in other cases it might be, 5, 6, 7. Sources. One source may make up the majority of it, and then in other cases it may be, 5 or 6 or 7 different sources that all kind of have an equal hand. But Steve, do you want to talk a little bit about it kind of in the broader context?
Absolutely. So just scaling it up to the clean water plan level, and just from that, even taking that percentage piece as a scaling element, even if we knew, it's hard to get precise percentages of each pollutant coming in. And furthermore, if you have those, some pollutants at a lower percentage might have a higher impact than some pollutants at a higher percentage. So they're not necessarily comparable just on that percentage basis. So the Clean Water Plan, though, we went over earlier, the water quality parameters we're taking a look at in our introduction. So we're definitely bringing those in. We're looking at those in the context. We're going to get to looking at those through strategies in the context of their loading to receiving waters. So we look at it that context. And then we look at water quality outcomes. And I think we'll be able to get to, the hope is that we get to some of those aspects that we're talking about, like where we see the biggest change in outcomes relative to different pollutants and different pathways.
Thank you. Okay, looks like we will have time to loop back to some of the questions that came in on the previous presentations. So I'm going to read a question. Again, this came in during a previous presentation. Said, I thought this might be the section where you might talk about alternative treatment and management technologies. For example, waterless systems. Note a significant hurdle is also State Department of Health code requirements, not just building code requirements. Jackie, would you like to respond?
Sure. So yeah, Anna is absolutely right that there is a lot of intersection of different regulations that overlap, including the building permit, and there's also public health regulations. There is quite a bit of work that's occurred nationally. There is an organization that's a national Blue Ribbon Commission on-site non-potable water reuse. That's a lot of words together, but they've actually developed sort of model state regulations, local regulations, and then kind of local program models. So there are some tools out there, and we know that there is interest from the development community. There's been legislation introduced in the Washington State Legislature the past couple of years, directing the Department of Health to adopt a rule that would, allow the decentralized systems, set up a regulatory framework to allow the permitting of them. So I expect that, there'll continue to be some movement on the regulatory front on those decentralized components.
And we had a follow-up, says, sorry, what was the official name of the National Blue Ribbon Committee?
Sure, it's, let me just check its official title. It's the National Blue Ribbon Commission for On-Site Non-Potable Water Systems. My apologies to those that had to translate that. It's a lot. But if you Google that, you can find a lot of information about that.
Great. Our next question, would West Point have to be retooled to handle a greater solids to liquid ratio? Tiffany, would you like to start us off?
Sure. So this question came in relative to the decentralized actions. And so, yeah, depending, this points out that depending on the process we're talking about in our regional treatment plants, treatment capacity is driven by both our solids, influent solids loadings, as well as our liquids solids loading, or both, depending on the process. So we do know right now that our treatment plants are driven, the capacity is driven by loads. And so as we look out the 40-year planning horizon, there's times when we do need to increase capacity, a lot of the times due to solids loads. So with if the decentralized actions, again, if we shifted to doing something like that, we would need to look closer at how much it might change the timing of those constraints. But it wasn't something we specifically looked at during this analysis, but we do note it as a risk or something that would require further considerations. And a lot of it would depend on how the decentralized actions would be, if they were, how they would be implemented, and how large of a flow and solids loads might change for the influent to the regional treatment plants.
Thank you. Next question, for the building scale decentralized treatment, are there plans to retrofit existing developments, or would this only benefit new development or redevelopment? Steve, do you want to start off our response to this one?
Absolutely. On the retrofit of buildings, our building scale concept, we looked at large buildings, excuse me, I think greater than 100,000 square feet. Generally speaking, it's been looked at substantially by others over time. A retrofit of a building that size is not going to be cost effective, or it's not going to come out from a cost standpoint to work out to migrate a building from discharging to a centralized treatment system and going decentralized. So that's why we developed that concept and played it out as either a redevelopment of those Puget Sound Regional Council or urban growth centers. So complete, redevelopment of those areas, so new buildings.
Great. Thanks, Steve. Next, how does the building scale option wind up producing significant benefits on the environmental end, such as TSS or copper or zinc, when relatively little flows would be processed? Ian, do you want to respond to this one?
Yeah, maybe I might have misspoken if gave the impression that the building scale has a significant impact on the environmental. It is that of those decentralized treatment actions.
Ian, you're a little bit quiet. I'm sorry.
Is that any better?
Yes, that's better.
Okay. So of the decentralized treatment actions that I was discussing, the building scale does have a larger amount of the flows in the region are going there than the other decentralized. So it does have more of an impact on the environmental outcomes, but it's still on the order of 10% of the flows in the region by the end of the 2060 time period would be getting treated on site. So it's still a small portion of the overall flow. So I wouldn't characterize the environmental benefits as significantly improved.
Thank you. Just a reminder that if you do have questions, feel free to type those into the Q&A box. Right now, there's only one question left, but we do have a couple more minutes if you have further questions. Okay, so this question is, is King County considering any efforts to separate its combined system or a portion of it, i.e. to have completely separate sanitary sewer lines and stormwater sewer lines? Steve?
Sure. So the county has looked at sewer separation for many years for as part of its combined sewer overflow program. We will have a specific session like this on May 25th. It's our third of these actions technical workshops that will go over wet weather management. So we'll break down some more on the concepts, the actions for wet weather, including stormwater and CSOs in that session. Hopefully everybody can make that as well. And we'll daylight all those and bring that into the conversation, and we can talk about this separation aspect some more.
Thank you. I'm going to pause for just a moment here in case anyone else has a question that you are getting ready to type in. And I will remind everyone that the recording and slides from today's workshop will be posted online next week. Okay. I see we have a hand raised. I am going to go ahead and call on Peter Donaldson. Peter Donaldson, I'm going to allow you to talk and you can speak your question. Peter, go ahead and unmute yourself.
Thanks. I was trying to type the question to fill that last gap and wasn't fast enough typer. I just wanted to give a compliment. I really appreciate the well-organized and informative presentation. So thank you all. And I'll follow up with some or all of you, but I'm very interested in coordinating on high school curriculum development, middle school curriculum development for all of the King County school districts, King County Wastewater Treatment Division school districts. We have quite a bit of funding to help make that happen. So we're eager to connect the dots, at least on the next set of ratepayers. So let's please connect.
Thanks very much. Okay, and we have had one question come into the Q&A box. The question is, electric cars are only 3% of vehicles today, yet we are planning for major growth. Building systems reduce only 10% in your estimates. What if you are underestimating? Steve, would you like to respond?
Happy to get started. Then I'd encourage others that worked on our decentralized aspects to take a look. You know, I'll start at the very high level, and maybe some of the other SMEs can unpack assumptions. My high level assumption would be, you know, we looked at the trends that exist, the trends that we see. We looked at the feasibility of these. We looked at the technology tea leaves to see what was out there, and this is what we brought forward. Just like everybody will tell you, the one thing we know about any forecast of the future is that it's wrong. You know, our goal with the Clean Water Plan is to be, you know, as little wrong as possible, because we're just looking into the future here and doing our best based on the information we have available. So with that, I don't know if any other SMEs want to chime in with any specific of the trends or assumptions that we looked at on decentralization.
No, I think you hit it on the head, Steve. You know, we were basing those flows based on projections of growth in our region and redevelopment, and so it's tied a lot to that assumption about what's that square footage where we would assume that these are to be implemented, and then how much growth will there be in the region coming up. And I'm sure, like Steve said, projections tend to be not exactly right, so I wouldn't expect it to be exactly right. But I think it still provides kind of that representative view of what that might look like. So that if we're underestimating how many buildings are redeveloped or overestimating, we're still, you know, talking about in that ballpark of outcomes.
Great, and I think that is going to wrap up our questions for today's workshop. Thanks again so much to everyone who took the time to type in or speak a question. I'm now going to hand it to Sonia Landa Benahar to wrap us up.
Thanks, Darcy. So as we approach these last few slides, just want to thank everybody for sticking with us since 9 a.m. today. I want to share where we're going and how to stay engaged in this process. So what we discussed today was actions characterization, which is a fundamental understanding of water quality investment options. And next, we'll be developing complete water quality investment approaches for regional exploration, and these are called strategies. And eventually, we'll have an approach to investing the regional wastewater system and water quality. And throughout, it will be informed by regional input and technical analysis. So today we went through 2 decision areas, and we still have 2 more sessions coming up in May to take us through the rest of the actions in other decision areas. And the second workshop on wastewater system operations and health, where we'll explore different levels of investment in maintaining our aging sewer system and preparing for natural disasters. This includes information on capacity in our wastewater conveyance system, on-site wastewater management, and resource recovery. The third and final workshop will cover wet weather management, where we will explore what it looks like to treat more stormwater within our existing system. There will be actions shared that include CSO control, ways to optimize the way we operate our system, and ways to address legacy pollution. And in this series of workshops, we will continue to give you an overview of the actions, water quality performance, conceptual cost estimates, sustainability, and community characteristics. I want to point you to the resource that's available on our project site, which is called the Actions Technical Workshops Content Outline. There you will see an overview of each of the workshops to help you decide which one you might want to attend. And in the next step during the strategies phase, we also plan to host engagement opportunities to share with you the strategies and gather feedback from the public. Please be sure to subscribe yourself and your organization to the Clean Water Plan email list, which you can find at our project website under Join the Conversation. Finally, I want to point you to the great resources that we have in our project library, specifically to the actions document that was mentioned throughout this workshop called Actions Characterizing Water Quality Investment Options, where you can find more details on the information that we shared with you today during this first workshop. We'll also have future sections that will correspond to the workshops 2 and 3. Additionally, on our project site, you will find the video we shared with you at the beginning of this workshop. We also have topic sheets that describe the planning process and what actions are. We welcome you to reach out to us via email if you have further questions, or visit our website where you can find a lot more information about the Clean Water Plan. I just want to thank you all for joining us today, and I want to lastly mention that just shortly after this workshop, you should receive an email with a link to a 3-minute survey to let us know how you like the workshop. Please be sure to fill those out and give us your feedback. And additionally, as Darcy mentioned, you'll also receive a link to the recording of this presentation and the materials that we referenced. So I just want to close out and thank you all so much. Please take care, and we hope to see you at our next workshop on May 13th. Thank you.